Great. Well, welcome everybody to WeatherLive 2022. This is an annual event that the Royal Met Society runs, focusing on, I guess, topics of the day. And today's is very much topical on transportation and the impact weather and climate has on transportation. So delighted to welcome you all. This is obviously a Royal Met Society event, but it's run in association with AccuWeather, who have been sponsoring our Weather Photographer of the Year competition now for a few years, and I'm delighted that they've decided to link in with WeatherLive this year again. I've got a few housekeeping slides before we get into the programme of the afternoon, so if we can just move on to the next slide. I just wanted to make you aware of Met Matters, which if you go onto the Society's website, we have a tab called Met Matters. You can see the URL at the bottom of this slide. Lots of regular content put on the website on topics of all things to do with weather and climate. We often have guest blogs from people, some science lessons to help bring kind of weather and climate to life. Very much geared at a wide audience of people. So if you haven't seen our Met Matters web pages, please go and have a look. And if you want to sign up to a newsletter so that you receive updates on a monthly basis of news items that are coming on Met Matters, then again you can do that, and you can see the web page here. Next slide, please. I have to mention, obviously, the Royal Met Society is a membership organisation, so if you're not already a member of the Royal Met Society, please do have a look at our membership pages. Again, you can see the URL, the web page link at the bottom of this slide. All the different benefits of being a member of the Society, and I would encourage you to go and have a look at that and join if you wish. And next slide, please, final slide. So we're obviously on Zoom for this meeting. If you have any problems, I would recommend that you just exit the meeting and try and rejoin, making sure that you're using one of the 4 browsers that you can see at the top of this slide. You can close the chat just to enlarge the screen so you get a bigger view of the slides that we've got. And we will be taking questions at the end of each of the presentations, and also during a panel session at the end of the whole event this afternoon. If you have any questions for any of the speakers or for the panel, can you please put them in the Q&A, which you can see there's a tab for that as well. So please put your questions in the Q&A. Great. So without further ado, I'm going to go to our first speaker for this afternoon, and I'm delighted to welcome Erica Palin, who is an applied scientist at the Met Office, and she's worked there for about 14 years now, but she's been a fan of the railways, as she says here, for rather longer than that. She currently jointly manages the rail application teams and works with the rail industry to develop and provide weather and climate solutions. And Erica's presentation today is on keeping us on track when it comes to weather. So over to you, Erica.
Yes, thank you very much, Liz, and good afternoon, everyone. Can I just check my sound's coming through okay?
Yep, I can hear you fine.
Excellent, thank you very much. Right, I'll just share my screen then. Okay, so hopefully
and I can see your slides as well. Yes, perfect.
Perfect. Okay. Thank you very much. Well, good afternoon, everybody. I'm Erica, as Liz has just said. I jointly manage the rail applications team at the Met Office, and today I'm going to talk to you about how the impacts of extreme weather on our railways are now and in the future, and how these are managed and prepared for. So I'd like to start with a bit of history. So recently, I was lead author on a review paper about weather, climate and railways. And for this, I needed to explore the existing literature on this subject. And I wondered how far back in time I could find references to weather impacts on railways. So I did a bit of research in the literature, and the answer was quite far back. So in this paper from exactly 100 years ago, I found this rather lovely quote that sums up the challenge pretty well. Fate has decreed the battle of the railroads with nature a perpetual one. But that's the scientific literature though. There's actually more evidence further back in the press. So back in 2014, when the railway at Dawlish was damaged by the sea, I remembered reading a tweet by the journalist Leo Hickman that referenced a prior incident on the line from the mid-1800s. So following his lead there, I found the original article in a local newspaper on the 31st of October, 1846. So this excerpt from the article describes 8 breaches in the seawall at Dawlish, and a certain Mr. Brunel's visit to the area to explain how his railway would be restored to service. So weather impacts on railways are not new. They were happening 176 years ago. So how does weather affect our railways now? Most of my examples will come from our railways in Britain. Many of the principles, though, are broadly similar elsewhere, assuming climates with similar weather hazards, of course. In addition, this won't be an exhaustive list of all the weather impacts that might be seen, but I've tried to capture a range across hazards. And for some hazards, I'll talk about how the weather risk can be managed and mitigated. One management approach that spans all the hazards, you won't be surprised to hear me say this given where I work, is the timely and appropriate use of weather forecasting information and warnings to see when periods of elevated risk might be coming in order to enhance preparedness. And a further overarching aspect of management is the use of monitoring and inspection to identify at-risk assets so that the risk can be mitigated proactively. So let's start then with high temperatures. So rails, like most things, expand when they get hotter. Track in this country is typically laid with gaps between lengths of rail to accommodate some degree of expansion. But if the expansion exceeds that tolerance, then buckling of the track is possible. Maintenance of the track also can't be carried out in very hot weather, as disturbing the ballast beneath the track can increase the buckling risk. And the ballast is the stones beneath the track, by the way. Line side electronic equipment is normally housed in boxes like these that you can see in the middle of the slide, called location cabinets, and these can get much warmer inside than the ambient temperature outside. And this kind of equipment is often used in critical functions like signalling, so overheating can mean signalling failures. And in some parts of the country, trains are electrically powered by overhead lines. So on top of the trains are mechanisms called pantographs, which rise up and touch the lines to receive the power. Like rails, though, overhead lines can expand when they get hot and they can sag. Now, most lines nowadays are auto-tensioned with a weight system, and I'll show you a picture of that in a moment. But in areas where the tensioning is fixed, so on older overhead lines, or in cases when the sag exceeds the design capacity of the auto-tensioning system, you can get excessive sag and the pantograph contact with the line can be affected. I should say that I couldn't find photos of the location cabinets and the overhead lines actually experiencing impacts, so they're both behaving themselves in this picture. How can high temperature hazards be managed? Track buckling risk is managed in a variety of ways, including sending people out to physically monitor the track in hot weather. Temporary speed restrictions may also be applied to reduce the forces on the rail as the trains go over it, and thereby reduce the buckling risk. And we can also paint rails in high-risk locations white. You might have seen a few examples of this in the media during the heat wave this summer. Overhead line sag is not usually excessive on lines that are auto-tensioned, and here you can see the weights that do that auto-tensioning. But as I mentioned, there are these older lines with fixed tensioning, and on those, the height and the tension can be adjusted manually when hot weather is expected in order to reduce the risk of sag. And track maintenance is minimised or avoided, as I just mentioned, during very hot weather for the reasons just discussed. This is one of the machines used in maintenance. You can see on the bottom there, it's got these kind of yellow teeth that tamp the ballast, and that means lifting the ballast up and moving it underneath the sleepers again. Now let's look at the other end of the temperature scale and some cold weather impacts. So points which allow trains to move from one track to another can freeze up in cold weather, which of course limits the movement of your trains. And another way of powering trains is third rail traction, where electric power is supplied by a live conductor rail alongside the running rails. And the train contacts the conductor rail via what's called a shoe underneath. Of course, if the third rail ices up, the contact between the rail and the shoe is lost, and again, the train can lose power. Tracks can also be physically blocked by snow. This example is from Aviemore in 2010. And finally, in cold weather, any dripping water inside tunnels can freeze into icicles, which can sometimes become very large. This is certainly not the sort of thing a driver would want to encounter while driving a train through a tunnel. What can be done about cold weather risks? Well, good old-fashioned elbow grease is one method. So here you can see the snow being cleared manually. For points, heaters can be fitted, and those can be switched on and off remotely to melt any snow or ice. Specialist trains can also be sent out to clear the tracks. There are a couple of examples here of snow ploughing trains and another winter treatment train that has all sorts of exciting equipment on board. And with regard to tunnels, actions can be taken to seal the tunnel walls to make them less vulnerable to water ingress and therefore to icicle formation. Excess precipitation, a hazard that we experience commonly in Britain. The obvious impact here is flooding, whether it's of the track or of the line side. And excess precipitation can also cause problems with earthworks. Earthworks are the slopes on either side of the railway where it goes through cuttings or along the top of an embankment. The types of things I'm talking about here are washout or slippage of the material beneath the track. So you can see a couple of examples there, or landslips that lead to obstructions of the track. Flooding risk can be reduced via barriers. A couple of types are shown here. So there's a sort of inflatable, relocatable type and a metal variety that's kind of installed beside the railway in a particularly vulnerable location and deployed when required. Pumps can also be used to remove floodwater when flooding occurs. And in terms of prevention, there's a great common sense solution here is simply build your thing higher up. So these location cabinets up in Cumbria have been built on stilts, and you can just about see in this flood that they were well above the water level. I mentioned earthworks and earthworks failures. This is a notoriously difficult to manage risk. A lot of work has recently gone into this topic following the tragic accident a couple of years ago near Stonehaven in Scotland, in which 3 people were killed when a train derailed after it collided with landslip debris on the track. Inspection and maintenance regimes are one approach that allows any obvious issues to be addressed, but it's not easy to predict earthworks failures. And the Met Office is actually doing some work with Network Rail collaboratively on this topic at the moment. Unfortunately, very dry weather can also cause problems in some parts of the country where the railway is built on clay soils. So these soils shrink a lot when they dry out, leading to subsidence of the track. And here's an example from the summer just gone. You can see the track has basically sunk beneath the rails. And in the short term, this can only really be managed via speed restrictions. If you repaired the track while it was in this state, you wouldn't necessarily resolve the problem because once it started to rain again, the soils would swell up again, and then you basically have the opposite problem and need to do even more repairs. High winds, these are another common problem in Britain, can cause trees, branches or other objects to be blown onto the track or onto the overhead lines, again causing obstruction of the track or causing power failures. High wind risks can be managed through proactive vegetation management, so deciding where and when to cut vegetation back, through speed restrictions when very strong winds are forecast to reduce the risk of collision with any objects that might be on the line, and by sending out proving trains to check the line is clear before any passenger services are run. It is, of course, also important for the railway to liaise with its near neighbours about managing their wind risks, such as tying down their infamous trampolines. A bit of a roundup then for some other weather hazards. At the start, I gave you the example of Dawlish, so coastal infrastructure being affected by the sea state and storms. Here's a different case. You can just about see there, that's on the line near Dover in late 2015. Lightning can damage sensitive electrical equipment and in some parts of the world can start line-side fires, though this is less common in Britain. Most of the things I've talked about so far have been what we call single hazards, but actually combined hazards are also an issue. An example of this is the hazard of freeze-thaw. So when you get water filling the natural cracks in rocks and when you're in a marginal climate, so a climate where the temperature oscillates around 0 degrees, this repeated freeze-thaw action can gradually expand the cracks in the rocks. If you've got a railway that passes through a rock cutting, you will find there's a correlation between periods of intense rainfall, low temperature, and rockfall occurrence. And I'm sure many of you are itching to see if I'm going to include the next hazard. I couldn't possibly leave out the classic leaves on the line, could I? So during autumn, leaf fall can be quite a challenge for the railways. As trains pass over leaf matter on the track, it gets squashed onto the railhead, as you can see in this picture. And in the often drizzly or foggy conditions of our autumn, this basically becomes a filmy coating on the rail. Now, this affects the grip of the wheels on the rail such that trains have to be run at lower speeds because they can't brake so efficiently. And as you all know, that plays havoc with the timetable. As well as running trains at lower speed, leaf material can actually be blasted off the track by these specialist trains, which also apply a sandy material to the track once it's been cleaned. And that sandy material helps to increase the grip between the wheels and the rails. So that's a few examples of how weather affects our railways now. But what about the future? Well, this slide shows some examples of projected future climate changes in the UK. And I'm aware there are a lot of words on here, so I'll pull out some key aspects. Fewer frost days, less snow, rainfall that's more extreme, rising sea levels, milder winters and hotter summers, more frequent hot spells. I mean, really, the key point here is that climate change will change the frequency and or the intensity of some of our weather events. And because we've seen all the ways that weather affects railways now, that will therefore change the ways, again, in the frequency or the intensity that weather affects our railways in the future. So human systems then, of which railways are one, must therefore take action to adapt to climate change. Here's a definition of climate change adaptation from the IPCC. The part that concerns us is in bold here, and you can see it's about taking action now in order to reduce harm and capitalise on benefits later. What does adaptation need to do? Well, there are many ways to classify the goals and types of adaptation, but I quite like this one because it's nice and alliterative. Everything begins with an R. So one goal is to increase robustness. This means reducing risks by enhancing protection from hazards, which reduces the asset's vulnerability to the hazards and allows the railway to continue operating in a wider range of conditions. Another goal is to provide redundancy. This means ensuring the existence of additional or alternative capacity to allow services to continue even if a particular asset can't operate. Now, for example, when that Dawlish breach happened in 2014, that's the only main rail route into the rest of Devon and Cornwall beyond Exeter, and that was interrupted for several weeks. So there was effectively no redundancy unless you count switching to an alternative mode of transport. A final goal then is to enable rapid recovery. This is about making sure that infrastructure managers have the capacity to respond effectively and in a timely fashion to reinstate damaged infrastructure and therefore allow services to start operating again. Some other versions of this classification also include another R, increasing resourcefulness. That is, increasing the ability of the system to cope with some degree of impacts and therefore to continue providing a service despite impacts occurring. Most of what I've talked about so far has been taken from material that Network Rail have on their own websites, and I really want to emphasise the fact that they have been working and have been working for several years now to prepare the railway in Britain for future climate change. Obviously, I don't have time to go into lots of detail, but here are some milestones from their activities in recent years. So in 2017, they published a Weather Resilience and Climate Change Adaptation, or RACA strategy, and this was followed in 2019 by some guidance notes for their staff on assessing current and future climate risks and how to plan climate-related actions. In 2020, they updated the RACA plans for the routes. I should have said, sorry, that Network Rail is divided up into routes and regions, allowing for the railway to be managed in a more localised way. And in 2021, they brought together information from various risk assessments for their routes and assets into one integrated climate risk assessment. I'd now like to zoom out and look at some examples of infrastructure adaptation measures that demonstrate efforts from around the world to increase future railway resilience to weather. In the next couple of slides, I've attributed each measure to a country, but the measures are often found in other places besides those I've identified. Now, I've mentioned Dawlish already. Here, the seawall is being upgraded to be more resilient to rising sea levels in the future. And if you like big engineering, there's a marvellous thing here called the Wave Walker, which is a walking barge that was used during the upgrade work. And if you like time-lapse footage of things like this, you can find plenty on YouTube. It's really fascinating to see it walking its way along the coast to enable easy access so that the upgrade work progresses at different points along the coast. The middle picture shows drainage systems being installed on the relatively new Borders Railway in Scotland. The drainage systems are larger than those previously used on British railways, and that's to make them more resilient to projected increases in heavy rainfall in future. And with regard to buckling risk, in some places, commonly on high-speed rail systems, this thing called slab track is used. This is an example from Japan. As we've seen, conventional track is ballasted, so it has the stones underneath it, and that kind of track is cheaper, but it can buckle more easily and it needs more frequent maintenance. If you use slab track, you reduce the buckling risk because, as you can see, the rails are more constrained by the slabs beneath. Slab track also needs much less maintenance, but it is more expensive to install and it is potentially more noisy as well. In the USA, in stretches of track prone to rock falls, these LiDAR optical fences are used. So LiDAR sensors are placed regularly along the vulnerable stretch of track, and you can see that they basically are able to detect sufficiently large obstructions, allowing trains to be slowed or stopped before they reach any obstruction. And this is a specific example of what's called remote condition monitoring that's used quite a lot on modern railways. And one last example here about a very specific engineering challenge, which is from the Qinghai-Tibet Railway, and that railway is built on permafrost. So here, in order to extract heat from the railway in winter and to offer some resilience to the degradation of permafrost, there are these ventilation pipes built into the embankment beneath the track. So the measures I've shown you so far are all what we call hard adaptation or grey adaptation solutions. They involve technology or engineering, but adaptation isn't only about these solutions. A few years ago, I was working on a project that required me to research resilience and adaptation measures from railways around the world. And that project allowed me to come across my favourite adaptation measure, which is the Swiss Railways' use of these lawnmower sheep. So these sheep can get to places that mechanical mowers can't get to, so specifically particularly steep embankments. Why do I think this is adaptation? Well, managing vegetation on slopes can help to stabilise those slopes. So the sheep could be doing their bit to reduce the vulnerability of those slopes to failure. Adaptation can also have co-benefits. In this case, the sheep are more discerning than the mechanical mowers. They don't just annihilate all the vegetation, they just eat the grass and they leave any wildflowers alone. Now, this is good news for the biodiversity of the railway, which is another important aspect of environmental protection alongside adapting to climate change. This is one example of what's called a nature-based solution. So it's a solution that works with the environment rather than against it. Now, one final type of adaptation I'd like to mention is soft adaptation. And this is adaptation that basically centres around measures related to policy, law, socioeconomic factors, and management factors. A good example of soft adaptation is this partnership between the Austrian National Rail Service and its weather services provider. Now, a key element of this has been their jointly developed bespoke weather information system. This provides them with severe weather alerts and forecasts for the network, but it also allows local rail staff to input weather observations, which enhances modelling and supports decision-making. Wider stakeholder engagement as part of the adaptation process is also very valuable. So the Austrian railway operator engages with partners to jointly plan and implement adaptation, thereby allowing information exchange and cost sharing. And this is done through sort of formal standardized processes that are fixed in regulations, but also informal elements and ad hoc negotiations as well. So that's given you a flavour of how railways are planning for the future. It's now time for me to summarise the topics that I've covered today. So weather already affects our railways in various ways, and climate change could affect the frequency and or the severity of those impacts. Weather is actively managed now, however, in the present day, in order to keep services running safely, reliably and efficiently for as much of the time as possible. But our railway operators have their eye on the future too, and they're planning for climate change, which includes taking adaptive actions in order to reduce its potential future effects. And finally, the nature of infrastructure is such that so-called hard adaptations are a popular choice. However, nature-based solutions and soft adaptation measures are needed too. These can sometimes be less costly, more straightforward to implement, and what we call a lower regret option. So in closing, I'd like to return to the quote from the start of this talk, and a century after it was written, I'd like to append my own thoughts. So yes, I think the railways may always be doing battle with nature, but I also think that nowadays we definitely have better ways to fight that battle. So I'll finish with a very quick acknowledgement slide, just to acknowledge that Network Rail, as I said, provided a lot of material from their website in support of this talk. And there are a few more references there if you'd like to pursue any of the things that I've shown, including my own review paper there near the bottom that I mentioned at the start of the talk. So thanks very much indeed for your attention, and I'm now happy to answer any questions you might have.
Great, thank you very much, Erica. Can I suggest actually we go back one slide and maybe leave the list of links so that the audience can kind of view and make any notes while we're going through Q&A. So that was brilliant, really excellent overview. And so if anybody's got any questions for Erica, please put them in the Q&A. And while I'm waiting for questions to appear, I had a couple myself actually. So the first you mentioned about the earthworks, so the Met Office are involved in a project that's looking at how we can help with kind of landslides and when we get heavy rainfall events. Could you just say a little bit more about that, please?
Yes, I'm not sure quite how much I'm supposed to say or allowed to say at the moment, so I better keep it light. But essentially, different types of earthworks fail under different circumstances of rainfall. So some of them fail when you have an enormous sort of dump of heavy rainfall in one go, so an extreme rainfall event. Others are more likely to fail if you have sort of several days of rainfall leading up to that failure. So that's the kind of thing we're basically looking into at the moment. And then if we can find some sort of relationships between failures and rainfall parameters like that, we could then look at how that could be used in a predictive system.
Great, thank you. And I just noted in the adaptation measures, there was no measure of wildfires. Is that something that's being considered? Obviously, not a serious problem here in the UK yet, but probably going to become more prevalent, and whether there's any lessons that can be learned from other countries that have struggled much more with wildfires over recent years.
Yes, thank you. And that is one thing you're absolutely right, I didn't include. And there have been some fires, as we probably many of us have seen during the last summer. I'm off the top of my head, I'm not aware of what's being done about that, but you're absolutely right in the sort of sense that it is important to learn from other countries. And that's part of what that project I mentioned was doing. It was gathering a compendium of measures from around the world to see what we could learn in Britain for our railways. So apologies, that doesn't quite answer your question, but you're absolutely right that wildfire risk is projected to increase in the UK in the future, and that is something that will probably need to be managed more often. One of the things that can be done, I believe, is you can choose to plant different vegetation beside the railway line, which is more resilient to the occurrence of fires, and I guess also prevents them spreading quite so much. But I don't know a great deal about that personally, I'm afraid.
No, that's fine. Thank you. Okay, we've got a question from Isabella. So this relates to the sheep that were the kind of lawnmower sheep. How do we keep the sheep off the tracks? Is it difficult and expensive? Obviously, if we had to fence all the tracks to do that.
A great question. I'm afraid I don't know the answer. Yes, I guess maybe they're only deployed in areas where they have to be. I'm honestly not sure. It's not something I know a great deal about other than what I've already mentioned. Sorry.
Brilliant, thank you. So just a quick question again from me. So you mentioned about painting the tracks white, and I did see some images of that over this summer when we had the extreme heat of 40 degrees, some examples of that. How widespread is that in the UK? Is it relatively new, something that's just been trialled in the last couple of years, or is that being rolled out quite significantly across the country?
Well, it's certainly something I've seen used a fair bit around the UK, and I've seen it over a few years as well. So I don't think it's a new adaptation measure, but I think it kind of rose to prominence as you said in the summer heat wave this year. I've certainly seen it on lines outside Paddington. I believe it's used in other parts of the country as well. It's particularly only used in high risk places. And there I'm talking about things like if you have the rails running east-west, because then they basically have sort of maximum solar gain during the day, and it's a more sensitive location to being directly heated by the sun. And so it tends to be used in particularly high-risk locations like that. It's also used in other countries. I've got a photo somewhere that someone sent me of it being done in Italy as well.
Great, thank you. So a question from Malcolm. Because of the yearly differences, so obviously we see variation in weather patterns from year to year, how do the Met Office and National Rail interface with each other about the timeliness of RHTTs and preparation of snowplows?
So RHTTs, I think, are railhead treatment trains. I think just for the record, the Met Office actually isn't the weather services provider for Network Rail. That's a different organisation. But we do, of course, provide severe weather warnings through the National Severe Weather Warning Service. So we work essentially collaboratively with Network Rail through that kind of thing. So I think the answer to the question would be that's probably a question for the other organisation that are Network Rail's weather services provider, I'm afraid.
Okay, great. So there's a couple more questions appearing, Erica, but I'm going to wrap up there. If you've got time to just answer the questions in the Q&A, that would be fantastic. But I'm going to move on to our second speaker this afternoon, and we're moving from railways to roads now. And I'm delighted that we've got Tyler Royce joining us from AccuWeather. So Tyler is a meteorologist. He's been working at AccuWeather now for about 10 years. He started his career there the week that Hurricane Sandy struck the US, and I guess a memorable event, particularly across in America. He's been lead European forecaster since 2015 and has shared his extensive knowledge of forecasting for Europe, both internally but also externally. And Tyler's certainly spoken at WeatherLive events before, so I'm delighted to have you back, Tyler. So you're looking at treacherous travel, and over to you, Tyler.
All right, let me pull this up.
So I think, Erica, you might have to stop sharing yours. Yep. Great. Brilliant. We can see that, and I can hear you, Tyler. Brilliant.
Excellent. So it is wonderful to be back here again. And yeah, my talk is kind of the bread and butter of what AccuWeather does in terms of serving our clients, not just the public, but on the private side here. And the great thing here is we're celebrating our 60th anniversary this year, and actually the quote unquote the birthday, it happens to be next month. But besides providing services for school districts, for public works at a local level, so like a town, city, village, to a county level, or regional level, or even to the state level, we've been going on for 60 years. We have a team of 500 members across the globe, mainly located here in the United States. Over 20% of that, it happens to be all meteorologists. And so our headquarters all across, headquarters here is in central Pennsylvania, but we have offices all across the world, including Wichita, Kansas for severe weather, Dublin, Ireland, Paris now with Plume Labs, Seoul, Tokyo, so all over the world here. And when this topic came up, I thought, let's start off with some facts before we really dive into why extreme weather is so impactful to the roads. And really over the last 73 years or so, the amount of vehicle travel has increased 14-fold globally, and just even in the UK, it's 12-fold. So it's more vehicles out on the roads with any types of weather, the more likelihood you're going to see impacts happen. And over these times, you see that the Americans drive the most, but China has the largest number of vehicles globally. But those who have the most licenses per se happen to be the United States and much of Europe, while globally you're looking at a much smaller percentage. So you're talking a lot of people driving, and that's as of 2018, you're seeing that of those who travel by the road, close to 90% are doing it by the road instead of rail, and 78% of freight goods are moved by the road, which contributes to 13.2 billion pounds to the UK economy. So the weather impacting roads is extremely important in terms of the economy. And we see that just not even just in the UK, but globally, whether it's in Pakistan with the floods last month, back in August, September, or you see it in Florida in the United States from Hurricane Ian. And not surprisingly, vehicles get more used in the extreme weather cases. So when it's raining, when it's more windy or it's snowing versus when it's partly sunny outside. And so to kind of set up some of the rest of the talk, some of the busiest times happen to be June in the UK, and then Fridays, shockingly, happen to be the busiest day of the work week, with the evening commute being the busiest. So we kind of pare down of when in a given day it is, and then over the weekend it happens to be midday or around at that lunchtime that it happens to be the busiest. So out of all these times where we have all this traffic going on, whether it's slow commute or just a midday or on the weekend, Holtz Auto has kind of gone through and created these graphics here of when we have these accidents that are caused by the weather. And for the most part, the majority of them, the serious or slight, even the fatal ones, typically happen under sunny, no windy, or now no high wind conditions. But you can start to take a look at when there's raining and there's no high wind, just how vastly different it is compared to the other weather phenomena that are listed here. And they also did a survey with Admiral of about 2,000 drivers in the UK. And the interesting thing that I think is very important, and it's just not for the UK, but if we were to do the same survey here in the United States or any European country, Japan, Australia, New Zealand, we probably find the same thing, is that 50% surveyed said they would ignore severe normal flood warnings. And I thought that's very telling, that people who we are as meteorologists communicate to are not taking us severely when we're saying, hey, such and such road is flooded or is experiencing major flooding. Don't drive through it. And that leads to that next point, is that 16% in the UK didn't realize that they could invalidate their insurance by driving through flooded waters. And even if you saw any footage from Hurricane Ian following the storm surge, people driving through, it's just, why are people driving through these waters? Or if you saw in Pakistan, once the water started going down, is why? Or even take a look at Honduras and Dominican Republic or Puerto Rico after these roads are flooded. Why are we driving through? And we'll get into into the flooded roads in a bit, but I kind of wanted to start with, and kind of ties into what Erica talked about with rail, and that is heat. The biggest thing here is as we've all you guys definitely over in UK experiences the true extreme heat this summer, and then you talk about last summer up in the Pacific Northwest here in the United States. But the asphalt it's very sensitive. So when it gets really, really hot, it gets really soft and it starts to buckle. When you talk about concrete, like some of our roads here in the United States are concrete based. Well, they're made at slabs, and those slabs put together, once it gets hot, it wants to expand. But if there's not enough room to expand, it starts to buckle. So going forward, these are going to become much more bigger concern globally with these more intense heat waves, just not in the UK, but not just in Europe, but even here in the United States, in China, in Japan, in Australia, as we see these temperatures. And so some things that have started to help rectify that, to help prevent, at least with asphalt, is to start, quote unquote, painting it with lighter colors. I know in LA they started to do this. There's also there's another city that started doing that this summer, and I can't for the life of me remember it, but they started to put a coat down that is a lighter color so that the asphalt doesn't really reflects more of the sunlight instead of really absorbing it. The next thing is in Phoenix, they started rubberizing the asphalt, started putting some rubber material. It's like little balls of rubber, and it kind of softens the asphalt up to where it doesn't to buckle. And they purposely put that on commercialized or busy roads and city streets. And then finally, this was a paper that I was reading. It said called for a thickness of the asphalt to increase, and that should help with the to prevent the buckling with that. So heat right now it necessarily doesn't make that big of a difference, but going forward, it is definitely going to. The next one is definitely winds and windstorm. Now, it's not necessarily every time there's a windstorm coming through the UK or parts of Europe that these winds are going to always lead to difficult travel, but you get any crosswinds, you're going to interfere with the stability of the vehicle. Any lorries or trucks over here in the United States, new crosswinds, the idea that it could be blown over is definitely much more higher. Or in various parts of the world, like in the plains or in the desert southwestern United States, you can get the dust storms, or you get the tumbleweeds to go through, and all of a sudden you're surrounded by all this stuff that you did not anticipate, and it's going to take probably a little while before you can get through. specifically more with windstorms, it's just not the coastal flooding at the exposed coastal areas of beaches, as we saw with Erica again, with the rail. It's the seawalls that you can get to the flooding, that if you have any major roads along seawalls that going to get these high waves coming crashing up, you're going to see slower travel with that. You're going to see some kind of flooding. And for kind of a tip-wise, forecasting-wise, in my opinion, from time doing this, is the GFS tends to have probably more reasonable wind gust forecast than other models. While the other models might catch on that there might be a steam jet, overall in the scope of things, the GFS tends to be more reasonable. And the European Extreme Forecast Index, the EFIs, are extremely useful to kind of give us an idea of how extreme this wind is. And then finally conveying to the public, we kind of here at AccuWeather, we kind of try to put the impacts into the forecast of what the damage, what the winds can do in terms of impact, damage, coastal flooding, travel delays, or making travel difficult in that regard. Going to rain and thunderstorms, this is where we kind of, it's going to be a theme I'm going to kind of harp on every single time here, and it is timing matters. We get drilled here that no one really cares about the amounts. If you were to say 1 inch of rain is going to fall, most of us go, okay, 1 inch of rain is going to fall, but can we really visualize it? But the timing matters. If that inch of rain is going to fall during the morning or evening commute, that's going to have much bigger impacts compared to that rain is going to fall over the overnight or at lunchtime, or if it's going to fall over a 24-hour period or an hour period. The example I use with my coworkers or even with school talks is, it goes to the major flooding that happened in Northwest Germany, Belgium, the Netherlands back in not this past summer, but 2 summers ago. Can anyone visualize what 6 inches of rain looks like coming down in 2 hours? I can't. But the duration then after timing matters, not necessarily so much the amounts, because if it's 6 inches over a 2-day period, okay, yeah, we're going to see some flooding. But if we have in a 2-hour period, the ground isn't necessarily going to be able to handle that. And you're going to see, especially if you have terrain, you're going to have major flooding issues going on. Again, timing matters. And that goes to the second big point here, is something that I've kind of remembered ever since going through driving school, is that the first 10-20 minutes are the most dangerous when you're driving in rain because of all the oil that happens to be out on the asphalt. When it mixes with the rain, goes to the top, or tires start to roll over, it makes the road slick. So the first 10-20 minutes are the most dangerous. And then as we get into different times of the year, in the autumn time, we have the leaves starting to come down. Well, the leaves are going to go all over the place on the yard, they're going to fall on the road, then the tires are going to blow them off to the sides. If they're near any storm drains where the water goes down under the road into those pipes, if the leaves are clogging it, you're likely to get, again, more flooding that way, going ponding around that area again. So people either have to drive around or they have to drive slowly through. So you're slowing down or impacting how the flow of travel is going. And then finally, in the winter and springtime, what we have to remember is, if you have any, here in the United States, we get this all the time, you get snow banks, and if it doesn't melt right away, but can last like an additional 1 or 2 months, and if they're not cleared from, again, those storm drains, it rains, it's going to take a while for that water to get under, so you have a threat for flooding that way again. Another thing here is, this happened in the United States back in 1996. So we had the blizzards of 96 in January, but what happened is it didn't stay cold right afterwards. It warmed up and it rained. And so you had a big flood after that. That is very memorable. And so you had all these rivers and streams that couldn't handle all this water start to rise up. And then you had many rivers, including some big ones here in the Northeast, that started to really overflow and set new records in terms of the height of the rivers. And you see that going on right now in Florida. The rivers are still very high, where they saw 2 feet of water from Hurricane Ian. that water just doesn't go up, it goes up and out, and it goes the least preventive, it goes where it can. So you try to put those barriers up, it goes where it has least resistance, the phrase I'm looking for. So we try to then go with our clients saying, hey, there could be flooding in low-lying or poor drainage areas. Or we say rain and wet roads may lead to travel disruptions. Some of it might just seem very like duh to us, but to the public, either they necessarily can't visualize that. So we have to tell them, we have to say, hey, roads can be flooded. There's a possibility of this, so that they have some idea going out that they can be encountering that. And if they do, the phrase that we use here in the United States, turn around, don't drown. We all know what the power of water is. And so that is something that we really have to worry about. So lastly, before we get into the kind of the winter side of things, we'll quickly bypass the tropical cyclones and hurricanes. And the one I want to hit here is, while we talk about wind and rain in the last 2 points, storm surge here. We all saw the footages from what Hurricane Ian did around Naples and Fort Myers. And again, so it hits the point that water is quick, water is powerful. It goes where it's least resistant, especially on coastal roads. We saw those barrier islands just off of Naples and Fort Myers, of how they have these bridges. The bridges are breached in several places, and that now they have to go back to what they were doing 30, 40, 50 years ago, ferrying people at best to these islands. So when it comes to tropical cyclones and hurricanes, we have to remember the power of the storm surge, that not necessarily to buildings or the beaches, but also to roads, that it can really impact how people can navigate, whether if it's off the outer banks of North Carolina, any roads that are exposed to any storm surge from any storm really are at risk to being impacted and cut off from normal society that way. Lastly, in terms of extreme weather, we're going to hit the winter weather side of things, which is where here at the global headquarters at AccuWeather we really thrive in. And again, timing matters. We just had a winter philosophy seminar earlier this week, and it's honed into us every single year just to remind us timing matters with that snow. If snow is going to start in the morning or PM commutes, that's going to lead to more snarls, more delays, more chances for accidents in the commutes. The duration, when's the heaviest snow going to fall? If the heaviest snow is going to fall between 7 and 10 a.m. and you're talking 1 inch, 2 inch, 3 inches of snow an hour, again, you're likely to get those traffic delays where people get stuck in the roads, like in Virginia this past winter. Or you think of in Dresden, Germany, back 2 years ago. You think of Madrid with Storm Philomena. You're talking a historic snowfall, red warnings for snow, and yet there was still a whole stretch of road in Madrid that traffic still got stuck in, even though they were warned that this is going to happen. There's going to be heavy snow, stay off the roads. You have to worry about the transitions. If you're going to see start off as snow, go to sleet, go to freezing rain or rain, that's much better for prepping the roads. They could pre-treat the roads like we do here in the United States. But if it's going to start with rain and then go to snow, you necessarily, or even ice, you necessarily can't pre-treat the roads, because the rainwater is going to wash away all that pre-treatment into the storm drains or into the grass on the sides or any of the vegetation. We talk about lake and sea factor and snow squalls. They're very highly localized. It's all dependent on wind direction, and conditions can quickly deteriorate. You could go from sunshine, visibility 10 miles to all of a sudden in 1 minute you go to a total whiteout and you can't see the vehicle in front of you. That's what these lake effect, sea effect, and even snow squalls in general can do. So we have to highlight that threat. And that's what here in one of the things that we're doing in the United States is specifically in Pennsylvania, New York, Michigan, Indiana, is putting up signs that say, hey, snow squalls today, travel conditions are going to quickly change, be alert. That's even led to a new warning being issued by the National Weather Service, snow squall warnings. That just started last year. It's very much like in the United States with on our phones, with tornadoes and flash flood warnings, that it's an alarm that no matter what, will wake you to alert you that this is happening. We talked about early and late season snow. Again, you're going to see lower amounts on the paved surfaces. A lot of our clients only care about the pavement, necessarily don't care about what's happening on the grass. But again, the low amounts on paved surfaces goes back to the intensity matters. If it's going to, let's say this happens all the time in Denver, it's 70 degrees yesterday, and today they're seeing a foot of snow. Well, that foot of snow can happen on the paved surfaces as well as the grassy surfaces or non-paved surfaces, because if they have a 6-hour period where they're seeing an inch of snow an hour, 2 inches an hour, that quickly builds up. It doesn't matter how warm it was the previous day. The intensity of that snow coming down can overpower that. So again, the intensity and duration of that intensity matters, because also the plows aren't going to be going out if it's snowing 2 inches an hour, because it's what's the phrase I want to use here? Once they plow it, it's going to be snowpack, so it's going to be filled again. So it's going to quickly, they're going to strategically place their guys or women out to plowing or taking care of the roads. Are the leaves still on the trees? That's another factor, because you could increase the threat for tree damage, power cuts, and things of that nature. And again, the EFIs from the ECMWF could be really useful here. And I believe I'm close to running out of time, so I'm going to quickly hit on one thing here, and that is small events preceding big events matter. We tend to always go for the big events, but those small events can still lead to be as disruptive as the big events can be as well. So these questions are to ask. I'll leave this up as I end my part of the presentation here. These are things that we were just kind of gone over here at work. I thought we could even be asking ourselves that as well. So this I will end, and I'll take any questions.
Brilliant. Thanks, Tyler. Much appreciated. Really interesting. And I think to get an overview, I guess, of the weather both across Europe, but as well in the US, it was interesting. You showed the picture with the tumbleweed. We don't get tumbleweed here in the UK, but we certainly get debris being picked up by strong winds and being blown onto the road. So yeah, fascinating. Right, we're getting some questions in. So the first one is about kind of how we can raise awareness of remnants of tropical cyclones that reach the UK, how we can raise awareness of those through warnings and impact forecasts. Is that something that AccuWeather, I mean, obviously you don't deliver the warnings here in the UK, but the changing nature of tropical cyclones, the very fact that they are getting much further north latitudes, they are starting to get closer. We've had a number of tracks that look like they're coming very close to the UK. Is that something that yourself as a European forecaster, how do you get those messages out in the forecast?
That's a very good question. We have this term that once it's kind of lost its tropical characteristics. So let's say like Fiona, once it got into Canada, it became extratropical. Well, for the public, they really don't understand what that means. And so a term that AccuWeather created, you're talking decades ago, I want to say maybe in the 80s, is tropical rainstorm. Because the impacts from, even though let's say using Fiona again, goes and becomes extratropical, the impacts from it still are the same. And primarily at this time, it's probably heavy rain. By hearing extratropical, someone's probably going to let their guard down. So as things happen of that nature, here at AccuWeather, we shift the forecast. Instead of saying tropical storm Ian, we'll say tropical storm Fiona, we'll say tropical rainstorm Fiona, or tropical rainstorm Ian. And we're still hitting those impacts that there's going to be heavy rain, that the flooding is still a threat, the winds or the storm surge or whatever is still an impact is still going to continue. And within the last couple of years, maybe I want to say maybe the year before COVID or whatnot, we introduced the real impact scale, which is a scale that doesn't look at specifically just the wind, like the National Hurricane Center, or what every tropical center globally looks at, but we also look at the rain, because the wind, a tropical storm can do as much damage as a Category 5 hurricane, and it'd be all because of rain. So we try to get out to the public that, hey, yeah, this is a tropical storm here, but you're still going to see a boatload of rain that's still going to bring impacts. So we kind of have to start to overall globally have to kind of shift how we message to get those impacts out there and not kind of remain in the same box that we all kind of grew up in that regard, to get the message out that, hey, if there's a tropical hurricane that's coming, let's say, towards France or towards the UK, that heaven forbid that happens, that the impacts, we can drive home that impact message that this is something serious to take notice of.
Mm-hmm. Maybe this is something we can pick up in the panel discussion later as well. Just thinking about, you mentioned it in your talk, Tyler, about warnings, but how people respond to warnings. And some people, might see a severe warning of flooding and then just take no action. It's almost like cross fingers, it won't happen to me. But maybe we can pick up on that in the panel discussion.
Yeah,
there are a few more questions actually in the Q&A. If you're happy to pick up and answer those questions, but I'm just conscious of time, so I'm going to move on to our next speaker. Thank you, Tyler. And our next speaker is Carolyn Gardner. And Carolyn works for Storm Geo, which is an organisation based out of Aberdeen. And she's a marine forecaster and has spent the last 9 years providing critical decision support for weather-sensitive operations across a wide range of industries, whether that's offshore oil and gas to renewables, passenger ferries and aviation. But the focus of Carolyn's talk is on cruiser liners. So it's keeping our cruisers shipshape is your title. So over to you, Carolyn.
Hi there. Hi, everybody. Thank you, Liz, for that introduction. I'm just going to share my screen now. There we go. And I hope everybody can see that okay. I'm assuming so.
Yes, yeah, I can see that and I can hear you fine. Thanks, Carolyn.
Good, perfect. Thank you. Okay, so as I said, I am a forecaster with Storm Geo. I joined them in December 2013, straight out of university, and have gradually built my way up. I am actually now the forecast manager for the offshore side based in Aberdeen. So I'm primarily focusing on offshore oil and gas, renewables, aviation, and road ice forecasting. But today I'm going to speak to you about cruise ships as well. So if I just move on. Okay, so like I said, we do a lot of different forecasting at Storm Geo, and that can range from everything to road ice, offshore oil and gas, aviation, like I say, renewables and ship routing as well. So what I'm going to do is basically I'm going to kind of run through an overview of ship routing and the things that we look at and everything that we have to kind of take into account when we're actually routing a vessel. And then I'm going to drill down and look at passenger vessels more closely. So I'll look at ferries and cruise liners or cruise ships as well. Okay, so before we even start routing a vessel, there are lots of different things that we need to take into account. So we'll be speaking with the masters, we'll be speaking with our clients and basically trying to really understand everything that they need to take into account when they are routing a vessel. So this can be anything from vessel type. I'll show you on the next slide. Different vessel types have different shapes, and that can affect the stability of the vessel, that can affect the maneuverability of the vessel. It can also affect how it handles different weather conditions as well. It might have worse limits or better limits depending on the shape. The vessel age can also play a part. So obviously the more modern vessels might be able to withstand greater limits. They might be able to withstand rougher seas, or they might be able to sail faster as well. That's also a consideration. As the other thing that we might be looking at is whether they are laden and the ballast and the stability of the vessel, because that can affect where they travel. They might want to avoid certain areas. They might need to avoid rough seas as well. The other thing that we will take into account is the ordered speed. There might not even be one. This can be things such as ETAs. So your estimated time of arrival in a particular port. If you've got a a cargo vessel, they obviously need to arrive in a port by a certain time, and they have a schedule that they are trying to follow. We can take into account other things such as comments from the master and any other sailing constraints. And the other concern is if your vessel is laden, what type of cargo do they have? So in a broad sense, cruise liners are passenger cargo. So their cargo is a passenger ship, is passengers. So they have lots of different things that we will need to take into account when we are forecasting for different vessels. So I'm not going to touch on all of those points that I just made, but I just wanted to show this picture. It's very crude, but it kind of shows you the different shapes of the different vessels. You can see chemical tankers, they tend to be quite short and they sit low in the ocean, so they're not so affected by waves that are hitting them from the side. But things like roll-on, roll-off vessels or your cruise ships, they tend to be, we call them kind of shoebox vessels. They have this kind of shoebox shape where they have very high sides. And you can imagine this is a huge surface area. And therefore, if you've got winds or waves or any weather conditions hitting them from the sides, this can cause some really big effects. They're not so affected from if you've got waves coming to the head of the vessel, and usually they can withstand greater conditions from this direction. But it's something that we have to take into account. The shapes of the vessels do impact the limits that they have when they're sailing. So once we have understood all of those different things that the vessels want to take into account, like I said, the vessel type, the age, their cargo that they have, and ETAs and things like that, there are then lots of different environmental factors that we consider, and then we'll put that all together into a route. So I'm going to touch briefly on these individually, but we'll look at ocean currents in a global sense. Winds, waves and swell, they're obviously much more kind of localized effects that are affected by pressure systems. And then we have our sort of special events such as hurricanes or local effects, such as different winds that we get that might funnel into different areas. And again, I'll speak about that in a little while. There's also maybe some other client constraints that we have to possibly take into account. If you're on a cruise ship that is an Arctic expedition, for example, it's traveling through cold waters, they'll be looking at icebergs or ice cover, and they'll need to take that into account as well. So we all know that there are lots of different ocean currents, and you can see that using these currents can really help your vessels move from point to point, particularly if they're doing trans-ocean routes as well. Obviously, cruise ships are normally kind of hopping from port to port, so they're much smaller routes. But in the big scale, you can see that obviously these ocean currents can help us a lot. In the summer, we have a lot of cruise ships in the Mediterranean, but during the winter, many of these cruise ships will do what we call a repositioning leg, and they'll actually transit across the Atlantic to the Caribbean, where they can then do a winter season, as it were, in the Caribbean. So this map just here, we've got the east coast of South Africa, and you can see we've got this ocean current running down the side. And we've given the vessel two routes, and essentially, although this route here at the top might be slightly further distance-wise, because they're making use of this current down the east coast of Africa, obviously that means that they can move faster without burning so much fuel. If they're having to take this route here, then to maintain a certain speed, then they might have to use more fuel that emits more emissions. And there's obviously a lot of other constraints that the vessel will want to take into account. That can take longer as well if they're having to fight against currents, for example. So if this vessel was traveling northwards, then they're obviously having to fight against the current. And again, that will use a lot more fuel to maintain a certain speed, and it will also give more emissions as well. So again, that can have an environmental impact. So once we've kind of looked at the global scale with regards to ocean currents, we'll then start looking at the more kind of localized effects. So things such as winds, waves and swell. You can see here we've got a map with the UK up in this top right hand corner, and there's a nice high pressure system just here, and then we've got a low pressure system in the Atlantic. So if we've got a vessel traveling from New York to the south of the UK, and we've got this big low pressure system in the middle, they might have limits for example, that they don't want to travel through any seas that are greater than 6 meters. So we can see here, this is a little patch where we've got seas, greater than 6 meters. There's a bullseye in there, about 8 meters seas there. So again, that vessel will be wanting to avoid this as much as possible. And we've then suggested that they would travel slightly further north of this system instead of obviously running into rough weather. So that's something that we have to take into account. And obviously these systems move. So it might be that we ask the vessel to, or we tell the vessel to slow down so that the storm passes to the south of them and then they can carry on with their route. Maybe the vessel can speed up to kind of outrun the storm and get ahead of it. Or maybe it can move slightly further north or slightly further south like we've done here. For the next one, we will also take into account special events, so things like hurricanes and your tropical cyclones as well. So we've got obviously a nice picture of a hurricane here, and on the chart here we can see it's actually not the same hurricane. I should mention. You can see here, this chart shows that you have very tight winds around the center of the eye. We all know that, and you'll end up with very rough conditions in this region here. So the vessels will be doing their best to avoid that. And again, that might be that they're waiting for this to pass, or they might be moving faster to get to port a day or two ahead of time, so that they are out of harm's way basically, or they may well be rerouting around the south of it. For example, if they were maybe traveling across the Indian Ocean here, you don't want them to be basically going right across the storm. You may well send them sort of down on a more southerly route so that they avoid that. So these are big scale special events that obviously affect global shipping channels, but there are also lots of local effects, and these can also affect your cruise ships as well. So for example, we've got here in the Gulf of Tehuantepec, you can see basically what happens is there's a mountain range with kind of a gap in the middle, and we end up with these winds funneling through this gap. You can see here we've got winds of up to 40 knots. So we're looking at kind of gale force winds, maybe even strong gales as well. And you can see that is increasing the waves quite rapidly just in front of that. So, and again, that will then radiate out from this region and can affect the shipping in quite a large area, even though it's a fairly localized effect. The other one, which we see in Europe, is the Mistral winds. And this normally occurs when you've got a low pressure system up here in the North Sea, and you've got a high pressure system in the Bay of Biscay or out in the Atlantic. These two will kind of join together, and you'll see your northwesterly winds blowing across France. So it's a cold northwesterly wind that can cause basically we can see winds exceeding 36 knots, which is basically gale force winds traveling right the way across France and into the Mediterranean. That can obviously whip up your seas, and you can actually get those conditions coming up pretty quickly in the Mediterranean. This is usually a winter or spring phenomenon, and it frequently lasts several days. So again, this can really cause quite dramatic effects to your any cruises that are in the Mediterranean. So what often happens, and I think I mentioned this already, but during the summer months when this is less likely or less frequent, we often see our cruise ships in the Mediterranean. But then in the winter, when this starts to become more likely, we then see our ships moving out to the Caribbean, so they don't get affected by this. So the other things that we might need to take into account is customer constraints. So there are emission control areas around the globe where you have to be very careful with how much emissions you're using. That might mean that your vessel has to travel faster through them, or that it has to reroute around them if it's particularly emissions hungry, so if it's emitting a lot of emissions. Also, areas of ice cover and icebergs. Some vessels are obviously equipped to deal with that, and other vessels are not. So again, it will depend very much on the vessel type with that as well. So this I just wanted to put this in. This is a map of emissions control areas, and they vary depending on what the boat is emitting. Some of them, they're only worried about sulfur, some of them are carbon dioxide as well. So it really just depends, and each vessel will obviously, each captain will obviously be aware of that, and they will take that into account. So once we've kind of got all of that information, we'll put it all together into kind of the big picture. And for example, here we might suggest 3 different routes for a vessel. In this case, they're traveling obviously from Le Havre out to New York. So yeah, we would basically kind of take all of this into account and then give them an optimized route depending on the things that they've asked us for, whether that's the fuel efficiency, whether they need the fastest route, whether they've got to be there on a particular day, you know, whether they need, you know, they're really constrained by a wind or wave limits as well. So we put all that together, and then our customers can then choose the most optimal route for them. So that's kind of a big overview of shipping in general, global shipping. And then I just wanted to kind of hone down a little bit more into passenger vessels. So I'm going to speak a little bit about ferries and cruise ships. So ferries tend to be shorter routes. Obviously, I've just spoken about kind of global shipping. Ferries, as we all know, that, you know, they tend to be much shorter routes. So they're traveling, you know, a day, well, within a day, you know, a few hours. Their schedule is very important. So they're obviously trying to keep to schedule as best as they can. Obviously, their main concern is passenger and vessel safety, but they're slightly less concerned with passenger comfort, for example. So, you know, if the seas are a little bit rough and you've got a few passengers being seasick, they're not so worried about that. Obviously, but as long as the conditions are still safe for the vessel to transit. They will usually have a limit across the route. So, for example, one of our customers is Northlink Ferries, and they travel from Aberdeen up to Shetland, Lerwick. And basically they have a 5-meter limit. Or it's actually, sorry, 5.5-meter limit. So once the vessel sets off, they need to know that across that route, because it only takes, I think it's about 12 hours to transit, they need to know that once they've set off, they're not going to encounter those 5.5-meter seas. They will also have port forecasts. So each individual port might have limits on winds and waves, both speed and direction, and also gusts as well. So depending on which port they're going to, they might have to take into account the very localized weather at that port. Cruise ships are slightly different. So obviously they are usually traveling slightly further distances than your ferries. Their main concern is your passenger safety, obviously, but comfort and experience. The last thing they want is everybody to spend a week being seasick and then to come off the vessel and be like, oh, I'm never going on that cruise again. So they really are concerned about making sure that everybody is comfortable and having a really good experience. They will also take into account port forecasts. So again, if they're going into a port, there might be limits based on that port. They might have a port which is called a tender port, where the vessel actually can't get into the port, so they have to anchor outside the port. And then they'll have smaller vessels that will ferry the passengers from the cruise ship out to the port. And those smaller vessels might also have limits as well. Again, those vessels, they might say, okay, well, we can travel, it's a bit rough, but warn people that, you know, they might not feel very well, and then they can decide whether they stay on board or whether they go into port. Cruise ships will also take into account vessel movement, vessel motion, so pitches and rolls. And I'm just going to speak about roll just now, or in a minute, because I think that's quite important. So as I already sort of mentioned, the main thing for cruise ships is safety, comfort, and overall passenger experience. They have their limits based on winds, waves, and swells, and including directions. And again, I'll look at that briefly in a minute. Individual ports will have limits, especially for tender ports, as I've already mentioned, and they do tend to kind of hop between ports. The issue that we have when we're forecasting for these vessels is that each vessel is very specific. So each vessel might have its own set of limits. Each customer might have its own set of limits. So there's lots of different things that we have to kind of take into account. It should also be mentioned that cruise liners or cruise companies have their itineraries designed basically to avoid the worst weather. So like I already said, you know, these repositioning cruises in the spring, where they'll move from the Bahamas back out to the Mediterranean, and then in the autumn, when we get those worse conditions in the Mediterranean, they'll tend to move back out to the Bahamas. So, you know, they're basing their itineraries to kind of avoid the worst weather if they can. So how do we forecast for this? So I've spoken about kind of those more global shipping routes. So that would be your route optimization. And we would use that very much so with these kind of repositioning, these repositioning legs. They also have scheduled route and port calls, but they're not so focused on that. They can reschedule a port, they can skip a port, they can go back to a port. And they're not so, you know, with passenger ferries, they really need to stick to their timetable, whereas cruise ships can kind of change them about. Vessel shape is very important. I mentioned that earlier, and we'll take a quick look at that in a second. And then we can also do a recommended speed for them as well. So cruise ships can actually move quite fast, and obviously they can go very slowly. And if they're just cruising from one port to another, they don't want to go too slow, because if they have got emissions that they're emitting, then obviously you don't want to kind of cloud that around the vessel if it's moving too slowly. So we can also give them a recommended speed as well. So as I've mentioned already, we have individual port calls. So you can see on this map, this cruise is hopping between ports. Pilot forecasts are very important. So they are forecasts that are just outside the port. And that can be especially for tender ports when we've got tugboats coming in. And also winds and gusts can be a really big issue as well. You don't want a vessel coming into a port and then bashing against the side. So vessels might maybe wait outside until their weather is better. Fog as well can be an issue. Obviously that will cause reductions in visibilities. If you're sailing between ports, the direction of the weather is very important. For example, we've already seen that cruise ships are fairly tall, and obviously they might only have a smaller limit of say 3 meters if their weather is coming onto the side of the vessel, but they might be able to withstand much greater limits if the weather is coming head on. So that's something that they will think about as well. Pitch and roll. So this is just an example of when you have your sea conditions coming from the side of the vessel. Obviously they want to avoid this as best as possible. Cruise ships can actually roll, I think it's about 60 degrees before they're actually in danger of tipping over. Obviously that's quite extreme, and they want to avoid your customers having that having that experience. So they have stabilizers which will help to mitigate that risk. The other thing I should mention is that cruise ships are built to move. They can outrun storms, so we can ask them to move faster, but they can also make up time as well if they are being slow. And they can also quickly move to sheltered locations to get out of the weather. Okay, I realise I'm running out of time here, so I'm going a little bit quick on the last few slides. But passenger ferries, obviously they have a much more set timetable and set limits based on winds and swells. And again, I've already spoken about their port limits, so they will be focusing on that as well. They also have sailing limits. So in this example here, we've got a route for Northlink ferries going from Aberdeen up to Lerwick in Shetland. And we give 2 points along the forecast, which are usually more exposed. And this will give them their kind of worst conditions. So they have a limit, like I said, of 5.5 meters. They usually see that through here. And we might see that again on Friday of this next week, where we've got this big low pressure system coming in, very strong winds, and you're going to get this sort of funneling effect through this Fair Isle Channel. CalMac ferries is on the other side, so they have a lot of ferries across the Western Isles, and for them we do kind of like a marine area forecast, and basically we look at slightly sheltered spots and slightly more exposed spots, and that gives them an idea of where they can move as weather conditions come in. Okay, I realise I've totally run out of time, but just very, very quickly. So the other challenges that we have with weathers, obviously the track of the systems is very important. Sometimes systems move faster or slower than we think they're going to. And basically we need to react to that and let our customers know if conditions are changing. Maybe they need to leave earlier or delay their departures. Movements of fronts, and again, winds, waves and swell. Changing climate, I know that's a big issue at the moment, or a big, what we're talking about that at the moment. We're not quite sure exactly how that's going to affect our daily weather. What are we going to get? More extreme conditions? What are the global and regional changes going to be? You know, are we going to need vessels that can withstand much more extreme conditions, or vessels that can move faster? And maybe in much of this changing world that we're going to see our customers relying more for us as a company, giving them customer support or weather support and helping them through these challenges as conditions change, as the weather changes. Okay, I have finished.
Brilliant. Thanks, Carolyn. Very interesting, really good overview. And so there is a question that we've got around the impact of swell and wind waves on vessels, but I think you covered that really nicely actually in the last half a dozen slides or so. I know this question came up before those slides came, so I think that has been covered off nicely. Just a very quick question from me actually regarding, are you noticing more vessels wanting routes across the Arctic, particularly during the Arctic summertime, with sea ice being massively reduced and opening up kind of routing options there? Has that been a trend over recent years, or are you expecting that to become an ongoing trend going forward?
I think it might well become more of a trend moving forward. We haven't seen great changes in that just yet, but I think it will allow us to move further, for vessels to move further north where they may have been unable to get because of sea ice. And we had that question previously, where we're seeing hurricane tracks, getting closer to the UK. And if they are traveling further north, we're going to see maybe more severe weather further north, and actually being able to reroute vessels further north would be, might be preferable in that situation. We haven't seen a great shift towards that just yet. But there is, I do think it could be something that we could use in the future if we needed to.
Right. And just another quick question for me. I mean, obviously some of the routing that you do is based on environmental impact. So these zones that you showed us on one of the slides for fuel emissions. Is there also any requests to kind of avoid where there might be kind of sea life? So where there's, I don't know, colonies of whales that are kind of breeding. Are there any routing requests to kind of avoid these places as well?
Yeah, so big vessels, sort of like tankers and oil vessels, cargo ships, that kind of thing. They are doing their best to avoid them. Obviously, they'll have to go slower if they're kind of encountering wildlife. There is a Marine Protection Act as well, where they are looking. That we're trying to protect our marine animals. So, but they do try to avoid those areas. There are other things on the other side of that. You might have, say, an Arctic cruise, an expedition cruise, which is actually trying to find those kind of animals as well. So I think there's kind of two sides to that. In the grand scheme of things, global shipping, they're doing their very best to kind of avoid those, sensitive areas. And we also have, marine protected areas as well, where vessels are having to make sure that they're not impacting on or they're not going into. But yeah, like I say, some of the sort of smaller expedition vessels, they might actually want to be in that kind of area. But again, they will have certain things that they have to do. So for example, noise pollution. So if you do have an area or a pod of whales going into the area, then they may well be asked to, or they may have to turn their engines off so that they are not causing any disruption to the wildlife through that. That's just one example of what they might do.
Brilliant. Thank you. Okay, so we're going to take a break now, just a quick comfort break. So we've covered rail, we've covered roads, and we've covered the oceans now as well. So after the break, we're going to take a look to the skies and also just the wider impact, I guess, on tourism as well. So if we can be back here for 22, please, and we'll start our next presentation then. Thank you. Okay, welcome back, everybody. I hope you've had a chance to just grab a quick cup of tea and take a quick comfort break, and also had a chance to look at the Weather Photographer of the Year shortlisted images and winners that were announced on Thursday this last week, just gone. Some spectacular images, as we always get each year in that competition. It always amazes me the kind of quality of images that we get from right around the world. So yet again, I think another successful year. Okay, so we're going to move on to our next speaker this afternoon. Delighted that we've got Paul Williams here talking about aviation. So Paul is a professor of atmospheric science at the University of Reading. He specialises in atmospheric turbulence, jet streams, numerical modelling and climate change, with a focus on weather-sensitive applications, including for the aviation sector. And he's pioneered research in the effects of climate change on aircraft turbulence and flight routes as well. And I think particularly the focus of this talk is on aircraft turbulence. So I'm going to hand over to Paul without further ado. Away you go, Paul.
That's great. Many thanks, Liz. So it's a pleasure to be here. Thanks for the opportunity to speak about this connection between aviation and climate change and weather. I mean, a lot of the time when people talk about aviation and climate change in the same sentence, it's going to be quite a depressing sentiment about how bad it is for the environment, how much flying we do. And in fact, related to that, you might have seen the news yesterday or this morning that a landmark agreement has been reached in Montreal this week to make sure that international aviation is net zero by 2050, which is very good news. But it's not the subject of my talk today. I'm going to turn that on its head and not talk about the contribution of aviation to climate change, but rather the consequences of climate change for aviation in terms of, modified extreme weather events. So, I mean, this is the outline for my talk, by the way, and it's not going to be a list of bullet points. It's going to be an infographic that I put together several years ago for the ICAO, that's the United Nations International Civil Aviation Organization environmental report. There are dozens probably of theoretical ways that climate change could modify the way we fly. I'm going to focus on 5 possible impacts that have been studied. So we have projections, we have figures, we have data, when we have an idea of the magnitude of the effect. So these will be the 5 I focus on in my 20 minutes today. And we'll go through them in the order that you would encounter them if you were taking a flight. So I suppose the first thing that could go wrong is that we know that lots of airports are coastal. We know that the sea level is rising. We know that there are storm surges, and this all adds up to the possibility of flooding of coastal airports. So I'll tell you what we know about that. The next possible thing that could go wrong is that if the airport's not flooded, a warmer air makes it harder to achieve takeoff. And I'll talk you through the science behind that and the evidence and the projections. The third possible impact is the possibility of more extreme weather, more lightning strikes, causing disruptions and delays once the aircraft is airborne. The fourth impact here is changing wind patterns, basically the jet stream shifting in latitude and strength could modify flight routes and journey times and fuel consumption because of the headwinds and the tailwinds that aircraft benefit from in the case of headwinds. And the final impact, the one I've worked on most really here, is the possibility of more turbulence, because as the winds become stronger and more sheared, we expect a lot more turbulence in those parts of the atmosphere that aircraft fly through as well. So I'm now going to go through these 5 and give them a few minutes each, and that'll be the structure for my talk. So let's talk about rising sea levels first. We know, of course, that the sea level is rising. The globally average sea level is rising by about 3.5 centimeters per decade. We can measure it very accurately using satellites, and the rate of rise is accelerating. We expect it to accelerate. And as I've said, many airports are coastal, and that's because people are located usually near the coast. So the people preferentially are located, if you look at a map of the world, within 100 miles or so of the coastline. And there are other benefits too to having airports near the coast. Fewer obstacles, because if you take off over the ocean, and less potential for noise complaints as well, if one half of the airport is just the ocean where nobody lives. Now, we know from a recent study that the sea level rise that would result from 2 degrees Celsius of global warming would put 100 airports around the world below sea level. Most of these coastal airports are only a few feet above sea level. Here are some in the US, 13, that have at least one runway within reach of a moderate to high storm surge today, but add on the effects of sea level rise from climate change, and this gets even worse. So we can see large international hubs here, like San Francisco Airport is just 5 feet above sea level. JFK in New York, 11 feet. Fort Lauderdale is only 5 feet above sea level. Miami. And actually Louis Armstrong International is below sea level by a couple of feet. Now, let's just focus in on, as a case study, I'll show you LaGuardia because I believe airports are already really being affected by storm surges, and sea level rise is only going to make that worse. This was LaGuardia Airport, completely flooded and closed for 3 days after being hit by the remnants of Hurricane Sandy 10 years ago. All of the tarmac and both of the runways were underwater, and the airport was essentially completely unusable. So this is already happening today. And actually, this was quite fortunate. The storm surge from Sandy did not coincide with the high tide. This could have been a lot worse. And I've seen estimates that the terminal buildings could have been breached by flooding as well if there was a coincidence in time between the high tide and the storm surge. So this is happening today. And worryingly, a paper published recently asserted that Sandy-like flooding of New York will happen once every 5 years by the middle of this century. So flooding this bad really becoming a once in a 5-year event, so becoming much more frequent because of sea level rise. And you can see here a little projection for different sea level rises. Here's LaGuardia Airport and John F. Kennedy Airport as well, both underwater for about 12 feet of sea level rise. And it's not just in the Western Hemisphere that this is happening. Here is a photo of Kansai International Airport in Japan after Typhoon Jebi 4 years ago. And as you can see, surface water covering the runways and most of the airport. Again, you know, a completely unusable airport. The storm surge here was over 3 meters high, which is the highest water level ever recorded in Osaka Bay. Well, let's be optimistic. Let's assume you get to the airport and you're taking a flight at some point in the future and the airport is not flooded. So that's good news. The airport's open. The next thing that can go wrong is aircraft struggling a little bit to take off potentially. And that's because warmer air is less dense, as the little graphics show at the bottom here. When you have cold air, the molecules are all very close together. They don't have very much energy, but as the air gets warmer, the molecules get further apart. They don't get bigger. It's slightly misleading. I didn't draw this myself, but the molecules don't get any bigger, but they do get further apart. And that means that the number of molecules that are available to lift the plane upwards is reduced when the air is hotter. In fact, for every 3 degrees Celsius warming, there's 1% less lift. Now, in many cases, that won't have any consequences because the plane will be well below its maximum takeoff weight. But if the plane is fully loaded, this could be a problem. Here's just a little sort of simple way of thinking about this. Of course, the calculation of the weight of the aircraft and the takeoff conditions is one of the most important calculations that's done by the pilots pre-flight. And just this shows you, it's a simple model, but it's good enough to illustrate the impacts of air temperature on takeoff conditions. What we do here is we take the altitude of the airport in thousands of feet and put a little mark on this axis. And then we take the temperature of the air in Fahrenheit on the left or Celsius on the right, and we draw a mark there as well. And we connect those 2 points together. And then we can read off here the increase in takeoff distance required from the reduced lift and the decrease in the rate of climb as well. How many feet per second does the aircraft move up in altitude at? So for standard atmospheric conditions, so a sea level airport at 15 degrees Celsius, that's our baseline here. And everything will be referred back to that. But now let's suppose we take that airport at sea level and raise the temperature to 40 degrees Celsius, which of course we saw for the first time in this record-breakingly hot summer in the UK. Well, now we can see that the takeoff distance required has increased by about 35%. So you'll need 35% more runway to take off than you would at 15 degrees Celsius. And of course, if that runway is not available because the runway only has a finite length, then something is going to have to come off the plane, passengers, luggage, cargo, or fuel, or some combination of the above in order to achieve takeoff. And the rate of climb is reduced by about 25% as well. And that could have consequences for noise near the airport. The aircraft will be nearer the ground for longer. Well, we've recently studied that at an airport in Greece, Chios Airport in Greece, using historical data. Of course, it's been getting warmer because of global warming at a rate of about 0.75 degrees a decade. Actually, the winds have been changing as well, but most of the effects here are coming from the temperature change. But the reduction in headwinds is also not welcome because a headwind helps the aircraft to generate lift. Well, we fed these temperatures and winds into an aircraft takeoff performance model for an Airbus A320, a typical medium-sized passenger plane. And we've found that because of the warming air, mostly, but a little bit of a contribution from the slowing down of the winds as well, there has been a systematic reduction in the maximum takeoff weight of an A320. It's been reducing by 132 kilograms every year. So that's roughly equivalent to one passenger plus their luggage every year, one passenger fewer who can be carried. And over the 30-year time in which the A320 has been in service, that's over a 4-ton reduction in the maximum takeoff weight. So this is something that is already happening and is only expected to continue, of course, as temperatures continue to rise. And there's a projection here for the future at an airport in the US, so this time for a Boeing 737, looking back historically since the 1980s and then forward in red using climate model projections towards the end of this century. This is the number of days a year where the air is so warm that the maximum takeoff weight has to be reduced by 10,000 pounds. That's equivalent to the weight of 50 passengers and their luggage. And you can see that that number of days a year has been increasing over the past few decades in line with the global warming that we know has happened, and is projected to continue to increase into the future by maybe up to 200% by the 2060s. So the third of my 5 impacts is more extreme weather. We know, for example, that lightning we expect to increase because of climate change. We know there's a relationship between temperatures and lightning. The warmer it is, the more lightning we expect. And just to show you quantitatively what those projections are, we expect a 12% more lightning flashes for every degree of global warming. And because we expect, well, we've already had 1 degree, and we expect another 1 or more degrees of global warming by the end of this century, you can add together a few 12%, and we might see 50% more lightning strikes later this century. This image, by the way, in the background is a NASA plane, a research plane in the 1980s that deliberately flew through 1,500 storms and was struck by lightning 700 times for research purposes to measure the impacts of lightning on the airframe. So there's a possibility here of more lightning strikes in future. And indeed, here's some evidence going back from 2010 to 2020 showing the number of lightning strikes annually. This is in the Arctic, where lightning is relatively rare because it's too cold normally for thunderstorms to develop, except in summer. But there's clearly been a very large increase in the annual number of lightning flashes in the Arctic Circle over the past decade. And that's clearly because of global warming. It's because of the warming that's occurred in the Arctic. And we get these data, by the way, because every time there's a lightning flash, there's a short burst of radio waves, and we can measure those using the worldwide lightning location network. And that's where these data come from. So more flooding at airports, harder for aircraft to take off, more lightning strikes and extreme weather en route. And let's come now on to modifications to the wind patterns that provide the headwinds and the tailwinds. What you're seeing here in the white vectors are the winds at a flight cruising level, so high up in the atmosphere. So we're talking about the jet stream. Each frame in this movie is 1 day, and you can see that the jet stream does varies in strength, it varies in position, it develops these waves called Rossby waves. And so an eastbound flight, for example, from New York to London will try to get into these tailwinds because it gets a free boost from the atmosphere and it can get across the Atlantic using less fuel because of the tailwinds. Whereas, of course, a westbound flight would try to get away from the headwinds, which slow the aircraft down. So the black line here is the eastbound route that makes the best use of the tailwinds. Now, climate change is potentially modifying the jet stream, its strength, its location on average over long decadal timescales. And in particular, we expect the winds to speed up. So in the panel on the left here is the wind in the upper atmosphere over the past few decades in meters per second. So here's the Atlantic. So a transatlantic flight might go along this sort of route where the winds are 20 to 40 meters per second. And the panel on the right shows the change by the end of this century, again in meters per second. And so you can see a speeding up of these winds by up to 3 meters per second, maybe. So something like a 10%, of the order of a 10% increase in the wind speeds. And of course, this has consequences. It means stronger tailwinds on an eastbound flight and stronger headwinds on a westbound flight. And we've been crunching some numbers. And we have indeed found, if we put flights through 20 years worth of simulated winds in a pre-industrial kind of climate in yellow, and then a climate change simulation in red, we do indeed see that the eastbound journeys, there's obviously a distribution here. It's not the same flight time every day because the winds wax and wane. But on average, as we crank up the carbon dioxide in this model and the winds accelerate, we see a shift towards shorter journeys, and indeed the probability of a really quick crossing in under 5 hours and 20 minutes flight time more than doubling. And conversely, unfortunately, for the westbound flights where the headwinds are stronger, the journey times shift to longer journey times because of the headwinds. And I think we might see some really delayed arrivals into into North America. Because the headwinds are so strong that the flight's just taken such a long time. And we don't know whether this effect is already happening. It's too early to say. The jet stream is very variable, but I will say that we've had some very fast flights recently. The jet stream has been said to have record-breakingly fast speeds, and the flight time crossing record for an eastbound transatlantic flight has actually been broken 3 times in the past 5 years. It was 5 hours and 16 minutes, and then 5 hours and 13 minutes, and now it's actually below 5 hours. It's 4 hours and 56 minutes is the current record from the jet stream being so strong. And I'll finish with turbulence, which is obviously a major issue for the airlines. There's something wrong with this plane if you look closely. It was flying through turbulence that was so strong that this engine broke off in the middle of the flight. It still managed to land safely with its 3 operational engines, working engines. There's a kind of turbulence called clear air turbulence that is caused by instabilities in the jet stream. So the atmosphere is said to be stratified. We've got dense air at the bottom, light air at the top, and that inhibits or tries to stop the production of turbulence. But then there's the wind shear in the jet stream, the wind speed increasing with altitude. And that is what tends to persuade clear air turbulence to break out. And as I'll show you, climate change is strengthening the wind shear, unfortunately. And we know that from observations going back to the 1970s. In a paper we published recently, the wind shear in the jet stream has increased by 15% since satellites began observing the jet stream in the 1970s, and we expect a further up to a 29% increase by the end of this century. And unfortunately, wind shear destabilizes the atmosphere and generates turbulence, and we've been crunching those numbers too, and found here this is the change in the amount of turbulence by the period 2050 to 2080. It happens to be in spring, but I could show you any season. You see these large increases of, well, hundreds of % more turbulence in the next few decades in these jet stream regions in the Northern Hemisphere and the Southern Hemisphere too, where the jet streams are becoming more sheared and turbulence is becoming more frequent and stronger. So not good news if any of you are nervous flyers. I think we'll see 2, 3, 4 times as much turbulence on flights in the next few decades. So I've come to the end. To summarize, sea level rise and storm surges threaten runway capacity. Warmer air is potentially making it harder for takeoff to be achieved. We might see more lightning strikes, about 12% more for every degree Celsius of global warming. The stronger jet stream speeding up eastbound flights and slowing down westbound flights. And there's a little asymmetry in the mathematics that I didn't go into, but turns out that the round trip gets longer. The eastbound flights get a little bit faster, but the westbound flights get a lot slower. And the round trip journey gets longer as a consequence. And finally, this fact that the jet stream is already 15% more sheared than when satellites began observing it. And we expect twice or 3 times the amount of severe clear air turbulence in the next few decades as a consequence. I'm going to leave you with a little animation of Snoopy admiring some turbulence in a famous Vincent van Gogh painting. And I hope I've left enough time, Liz, for a question or two as well. Thanks for listening.
Brilliant. Thanks, Paul. Really interesting. Some fascinating statistics there, I think, as well. Some data, obviously, as we see global temperatures rising, the impact that's having on the different areas that you've covered. So any questions for Paul, please put them in the Q&A. I wonder if we could go back a few slides actually to the jet stream, the increase in speed in jet stream. I just wondered if there was anything you could say about the position of the jet stream and whether that's likely to change as well, looking at the projections, the climate projections that you've been looking at.
Yes, there is. So I focused on the strengthening, but there is indeed a shift as well. It's moving further north. We already see that in observations. Over the past few decades, it's steadily moving north. Of course, it moves north and south from one day to the next, but just if you look at the average position over long periods of time, it has been moving north, and we expect it to continue to move north in the next few decades as well. So that could have consequences too. Eastbound flights will presumably start going further north, and this could affect, for example, air traffic controller workload. We might need more air traffic controllers up in Scotland rather than down in England to handle the incoming flights further north, for example, is a possible consequence that we haven't really studied yet, but I'm speculating there.
Yeah, interesting. Just another one, I guess. I mean, you've seen, like you say, the eastbound flights getting faster and faster. I guess if it's a nighttime flight, is there a limitation at what time these flights can actually land in places like Heathrow, for example, or are they just having to circulate until the airport opens? So you're not actually gaining much time in the end because you're kind of circulating above Heathrow before you can actually come into land, or are we actually seeing door to door landing, takeoff and landing speeding up as well?
Well, yeah, you're absolutely right. The first flight of the day is not allowed to arrive too early for fear of creating noise for the local residents. So yes, there are times when transatlantic flights arrive at Heathrow or could be any European airport too early and just have to fly around in a holding position for however long, half an hour. Obviously not good for the environment, putting all of that extra CO2 into the atmosphere. So yeah, I think we are seeing that.
And I guess the last question from me, and I know it probably is a talk in itself, but I know you've done a lot of work about kind of routings for aircraft to help save on fuel emissions. Obviously, as you say, the aviation sector is a big emitter of carbon dioxide, but if we can actually reduce that by sophisticated routing, would you just say a few words really on the work that you've been doing there, because I think that's really interesting.
Yeah, thanks, Liz, for the prompt. Yeah, it is good to have an opportunity to talk about that. So what's being shown here is the best route. We've calculated the best route. If there were no constraints, this is the route that would use the least amount of fuel. Now, actual aircraft flight tracks are not exactly on top of this best route. So there's a difference. Actual flight routes have historically been flying too long. And that's because the North Atlantic is a very congested region of airspace. So there's a set of tracks that aircraft have to use. They can't fly on any track, or historically they have not been allowed to fly on any track. Pleasingly, a few months ago, a decision was made to abolish those tracks, at least up to a certain altitude. And now flights can go on any route they want. And now they can go along these optimum routes and burn the least amount of fuel. I think that's a really exciting development and has the potential to save quite a bit of fuel. So I was really pleased to see that announcement from the air traffic controllers, made possible partly by COVID, and they could do some experiments because the flight density was so low. I think that's really exciting and has the potential to really cut the emissions from transatlantic flights.
Brilliant. Thank you, Paul. You'll be joining us for the panel in about 25 minutes time, but I'm going to move on to our final speaker now, and delighted to have Michelle Rutty here, who is a Canadian Research Chair in Tourism, Environment and Sustainability at the University of Waterloo. Her research explores behavioural response of tourists to environmental change, whether that's past, present or future, as well as the climatic risks and emerging opportunities for tourism operators and destinations in our warming world. So I'll hand over to Michelle.
All right, thank you so much. So let me share my screen. Liz, could you just confirm that you're able to see it?
Yeah, I can see that and I can hear you fine.
Perfect, thank you so much. Well, good morning from Canada. It is a pleasure to be here this morning, and thank you to Liz and the Royal Met Society for the invitation to share some of my research and insights on how climate change may impact the future of popular tourism destinations across the globe. And so for the next 20 minutes, we'll shift gears a little bit from transport to trying to understand what holidays might look like in a warming world. So given that you are all weather and climate enthusiasts, perhaps this needs very little introduction, but whenever we look at leading sectors or industries across the globe, tourism consistently ranks as one of the most vulnerable to climate change. And the reason is because tourism destinations are highly dependent on both climate and weather. And so climate dependent destinations, sort of key or iconic examples of this are things like the ski industry, which is of course predicated on cold temperatures and snowfall. And another great example of this would be sort of coastal tourism or beach tourism, which relies on warm temperatures and sunny skies. But even those destinations that are dependent on climate resources, all destinations are weather sensitive to some degree, meaning that the weather will either help or hinder the activities that tourists engage in. So whether it's something like sightseeing, we all know that it's a lot nicer to do that in comfortable temperatures when it's not raining or windy, but also things like hiking, things like being able to see vistas or views can also be limited by the weather. And so we have loads of studies that show this relationship between the importance of weather and climate and how it can impact spending at a location and so forth. Whenever I do a talk on that has an element of climate change, I just like to really quickly sort of summarize what the key takeaways are with respect to the latest research in this space. So of course, the IPCC, or the Intergovernmental Panel on Climate Change, is the leading international body for assessing climate change, and it provides a clear view of the current state of scientific knowledge. And in their latest assessment, which was released in spring of 2021, the language was clearer than it has ever been, that human influence on the climate is unequivocal, resulting in a warming of the atmosphere, oceans, and land. And the other key takeaway, I think, is that, quote, many changes due to the past and future greenhouse gas emissions are irreversible for centuries to millennia. So of course, that means that we are committed to change, and the tourism industry must respond accordingly. The other key takeaway is that we are experiencing unprecedented warming. So the scale of recent changes across the climate system are unprecedented over many centuries to many thousands of years. And each of the last 4 decades has been warmer than any decade that's preceded it since 1850. In fact, the hottest decade in over 2,000 years has just occurred, which was 2011 to 2021. And we're on track to set another record year in 2022. So the warming that we're experiencing will continue until at least mid-century, again, underscoring that climate change is not something in the distant future. It's happening now, it will continue to happen, and so we need to address it. So where we're going with this presentation today is we will look at major tourism markets and destinations. I thought it might be fun to look at sort of what are some of the headlines that we consistently see in the media, and how does that compare with the available scientific literature. So some of the key markets we'll look at are snow-based tourism, we'll look at the Mediterranean, We'll look at mountain recreation, or sometimes this is deemed as green tourism. We will look at golf, and of course, small islands and the impacts of sea level rise. And then to conclude the presentation, it's really sort of where I situate my own research, is that it's not just simply understanding climate thresholds. We really need to understand societal's response to these climate triggers. And what I hope you'll see through this presentation is that these two pieces don't always align. So let's start with perhaps what I think is one of the most common narratives we see in media headlines right now, which is this idea that ski tourism is vanishing. So I'm sure we have all seen these images where we see really narrow strips of snow, skiers on snow beside dead grass. And we see headlines such as these from CNN in 2020, "Love skiing, enjoy it while it lasts." Or Bloomberg, "Climate change is killing alpine skiing." Or the Daily Mail, "Ski resorts in Alps will be unusable in the next 80 years. And that's their emphasis on the word unusable, not mine. So what do you think? In the next few decades, will skiing vanish? Well, whenever I am asked this question, and media often reaches out to me to talk about this, one of the things that I think they find most surprising, and perhaps it might surprise you as well, is that the average ski season length has increased in North America. So this is data from the National Ski Areas Association. And as you can see, since the 1980s, average season length has actually increased by 14 to 50% across all ski regions in the US. And we see this similar trend happening in Canada as well. So again, there's this surprise that we are having increasingly warmer decades, yet ski seasons getting longer. The Olympic Winter Games is another sort of case study where we can see warmer conditions. Since the initial games in 1924 in Chamonix, France, up to Sochi, we have continually had warmer host cities. So as you can see in that figure on the right, it summarizes it nicely. From 1920 to 1950, the average temperature of the host city was 0.4 degrees Celsius. And between 2000s to 2010, it's increased to 7.8 degrees Celsius. And most recently, the Tokyo Games, they were impacted by extreme heat and heavy rains. And during the games themselves, they reached temperatures of 35 degrees Celsius with 70% humidity during competition days. And yet Tokyo was able to host the games and all of the events. This past week, this made a big splash as well. Saudi Arabia won the bid to host the 2029 Asian Winter Games. So this will be the first outdoor ski resort in a desert environment in the Gulf. So it's a $500 billion investment to host these games. Again, raising an eyebrow. Is ski tourism going to vanish when we have destinations that are increasingly warm, able to hold the sport? And so the reason we're seeing this is because when we think about snow-based sport tourism, there is essentially an arsenal of things that the industry has utilized in order to protect itself from weather variability and climate change. So even from the first games in 1924, as you can see in that top image, the Army used baskets to move compact snow from higher elevations down to the base of the mountain. And then over time, it got more advanced and more technology. So we start seeing large scale snow transfer and then snow stockpiling. And then 1980s, this was really sort of the turning point for the industry, and why we're seeing longer ski seasons at many resorts is because of the invention of snowmaking machines. And so that's really sort of what has protected the industry, and it's how places like Saudi Arabia are going to be able to have skiing at their destination because they can produce snow artificially. What we also see that's really interesting and not talked about very often, at least to my knowledge in the media, is that demand is incredibly resilient. Skiers want to ski sort of regardless of the type of conditions that they're experiencing. So one way that we can look at this is we can look at record warm winters and then see how demand has responded. So I did a study here in Ontario. It was the first one to look at sort of how the industry responded to record warm conditions. So in the winter of 2011, it was extremely warm here in Ontario, and it represented conditions we might see by mid-century under a high emissions scenario. And looking at average changes across the Ontario resorts, we saw that the season shortened by 17%. The skiable terrain dropped by almost 60% in the crucial month of December. That's particularly important for the ski industry because that's where they capitalize on the Christmas and sort of New Year's Eve holiday break. And we also saw fewer days with preferred ski conditions. So it was down by almost half. And while that's how the industry or the supply side responded, as you can see in the table, if you look at that bottom row, in terms of skier visits, it only declined 10%. So much less compared to perhaps what we might have projected given the changes in the ski conditions at the resorts. And there have been other studies who have similarly looked at this. So in the US Northeast, again, a major market for the ski industry, it was projected that in their record warm, under climate change, that skiing would drop by over a third, but in their record warm winter, it declined 7 to 11%. And similarly in Austria, through climate models, it was projected that skiing would drop by almost 70%, but in the record warm winter, skier visits only dropped by 7%. And so there's clearly a disparity between what is being projected versus what we're actually seeing. And a large part of that is because skiers are willing to engage in spatial or temporal substitution. Spatial substitution means that if their ski resort isn't open that day, then they're willing to travel somewhere else in order to keep skiing. And so this figure here at the bottom, you can see in Ontario where we have modeled based off what we observed in the record warm winter. And you can see that people were all willing to travel to Ontario's largest resort, which remains open even in marginal conditions. And we also see temporal substitution, meaning that if you were planning on going in December, but your ski resort isn't open or the amount of skiable terrain is low, you would simply just take that trip and you would go in January instead. So if you were going to go skiing 5 times in a season, you would still go 5 times, even though that season had been shortened. And so with respect to sort of is ski tourism vanishing, the reality is we're more likely to have resorts that are considered sort of climate winners. And so those resorts that are able to stay open, whether it's because of their size, their investment in snowmaking, or they're at a higher elevation or a more northern latitude, skiers are going to continue to travel to those locations. It's very rare that we see skiers willing to give up on the sport altogether. What's less clear is whether or not there's going to be long-term shifts in ski demand. So it's entirely possible that skiers may become intolerant if there are consecutive warm seasons with marginal conditions, or if there are consecutive seasons in which their resort opens late or closes early. We don't have any clear understanding on sort of what that long-term impact might look like. But as I hinted to, adaptation strategies will vary. So in the case of the largest resort in Ontario, what they're actually going to have to adapt to is crowding. If everybody is going to their resort, they're going to have to contend with sort of longer queues, for example, at the chairlifts. And so to deal with climate change, they'll actually want to invest more in infrastructure to accommodate more skiers, which again is sort of counter to what we might have assumed initially. But one thing that we definitely don't have a strong handle on and where we need to invest more time researching is whether or not there might be a loss of the beginner market. So what we do know is that of the observed decline in demand, it often is our beginner skiers that are less likely to hit the slopes. They're the ones who often are more likely to rent their gear. But if we don't get them sort of in the sport and hooked on the sport and becoming passionate, they are the ones that are most sensitive to variability, and they might drop out of the market, which could have long-term implications in terms of they're a feeder market, and we need to ensure that we sort of nourish that market to ensure that demand persists sort of for a longer period of time. The snow sport events, obviously, that are have limited capacity are at greatest risk. So our destinations that are attracting tourists for things like cross-country skiing or snowmobiling, outdoor ice fishing or pond hockey, which is sort of a cultural phenomenon here in Canada, those are the destinations that in all reality are at greatest risk because they just don't have the ability to produce snow or artificially freeze their surfaces in the same way that skiing and snowboarding can. But again, what I think is important is the media headlines, they sort of tell this story that the entire industry is going to collapse. But the reality is that the vulnerabilities are going to vary spatially and temporally. They're going to depend on where you are. If you're in more northern latitudes or higher elevations, obviously your climatic resources are going to be more protected. This one I am going to assume will be of interest to many of you on the call this morning, which is this idea that the Mediterranean is going to become too hot for tourism. Again, this is a narrative that's been in the media since sort of the late 2000s, about 2008, 2009, these headlines started coming out, and every summer we sort of see the same thing happening. This is from this past August. So Spain, Greece, Turkey, most Brits think holiday hotspots will be too hot to visit by 2027. And if I were able to, I would put in a poll in the chat box because I would love to know what you all think. Will it be too hot in the next 5 years? But what's interesting is in the media, you sort of see these conflicting images. You have images where it clearly looks hot and difficult to engage in tourism activities. And on the reverse side, you see beaches busier than they have ever been before. So what is it? Is it going to be busier or is it going to be reduced? And again, it's just this idea that the media often just talks about the Mediterranean as a whole. It doesn't break down sort of key tourism markets. So for example, perhaps being in Athens, right in the city might be too hot, but would you be willing to go to the coastline? So while this media narrative of the Mediterranean being too hot has been ongoing for several decades now, in 2010, myself and my colleague, we were the first to actually just ask tourists, what is too hot for you? And so we did a survey with 5 different European countries, so a huge survey, just asking people that very simple question, what would be too hot for your holiday? And what we found was that on average, temperatures over 37 degrees Celsius would be considered too hot for the majority of our respondents. But as we all know, we don't experience temperature in isolation. So while we now had a stronger idea of what might be too hot, what makes sort of a beach environment so enjoyable is because you're also experiencing the cooling effect that's coming off of the water. So in a follow-up study, I had the very, very difficult job of setting up a weather station on beaches across the Caribbean. And while I had my weather station running, I surveyed tourists and very simply asked them, given the conditions you're feeling right now, would you like the temperature to be warmer? Would you like no change, or would you like to feel cooler? And if you look at sort of the stress categories along the bottom, so this is based off the Universal Thermal Climate Index. So this is an index that combines all variables of the weather that you're feeling at the same time to understand your body's sort of thermal response. You can see that at temperatures over 32 Celsius, you'd be experiencing strong heat stress, and over 38, very strong heat stress. And if we look at how our tourists on the beach responded, even if you go all the way over to the far right side at 39 degrees Celsius, you can see that 62% of our respondents said they didn't want to experience any change. And in fact, 10% wanted to feel even warmer. And as part of this survey, we also had tourists sort of guess what the temperature was. And not surprisingly, most people were off by several degrees. And that's because when you're on a beach, if you get hot, you have that ability to simply go into the water, get wet, come back on the beach and cool down. So the reality is how tourists interact with their environment and with the climate, again, it's quite complex. So since that initial study that I did in 2010, A number of other colleagues have done follow-up studies asking public samples what they would consider to be too hot. And in addition to sort of beach tourism, we've also had people now look at an urban holiday. And you can see there that those are the too hot thresholds identified by a number of different studies. And it's much lower than what tourists want for a beach holiday. And again, that's not at all surprising. It's quite intuitive, but yet the media continues to foretell the story that the Mediterranean as a whole is doomed. This figure here on the right was done by a colleague who essentially had taken all of these too hot thresholds that have been gathered in the literature so far, and then modeled it across the Mediterranean to look at what locations would become too hot. So the top is a mid-range emissions scenario for mid-century. And you can see where the green all the way down to the orange, which is the majority of the Mediterranean, meaning that even for an urban holiday, it would still be considered acceptable. It's not until the bottom one, the high emission scenario, you're starting to see a bit more red, but overall, it's still considered sort of good, acceptable, or even marginal, and that's for an urban holiday. For the beach holiday, based off what we know in the science, it won't become too hot, at least by mid-century, even under a high emission scenario. Another one that we see a lot of media attention on is around glacier tourism. So again, a couple of headlines. We have melting glaciers and heat waves make famous alpine hiking routes impassable. So there's evidence of trail closures due to safety concerns related to more frequent heavy rains or due to melting permafrost that's steepening the ice and rock slopes and destabilizing moraines. And while climate change is primarily responsible for restricting access along traditional trekking paths in the alpine region, it's also opened up new routes into previously inaccessible areas as the glacier retreats. And these new routes are spurring new and renewed demand. We also have a longer summer season, and that supported a longer viewing season at some glaciers. And as the shoulder seasons of spring and fall become more comfortable in terms of temperature in mountain environments, we're also seeing more people engaging in these shoulder seasons. And then there's also this other interesting fact where we see on the right side, this headline, last chance tourism draws visitors as glaciers melt due to climate change. We're also seeing renewed demand in some of these more vulnerable climatic resources as people want to travel to these destinations before they disappear. And again, a large part of this is spurred by media headlines urging people that certain industries are going to vanish. And while there's no denying that if a glacier disappears, that visitor numbers would decline, there's also been sort of this, as I said, this interesting spin. So for example, in France, the melting glaciers have led to larger pro-glacial lakes, and that has attracted increased tourism to that region. And then we also have this market for last chance tourism. In a recent study, we looked at Canadian mountain guides and we asked them sort of how they are responding and adapting to climate change. And as you can see, the environment is clearly changing for these guides, but there was very little mention or concern that the tourism industry was going to decline or that guiding tours would decline. So rather, there's just a recognition that they need to adapt and accommodate to the changing environment. So as you can see from this quote, I have had to abandon traditional routes, modify other routes, and change the season during which certain routes can be guided. And he further noted that they have changed the timing of trips, especially on alpine routes that have lost their ice. So again, it's more about shifting the time in which tourism is happening as opposed to it disappearing altogether. With green season tourism at a mountain level, again, I've talked a little bit about this. We have a longer, warmer season. So there's a longer season for hiking, biking, camping, and climbing. So there are more opportunities to engage in tourism. We've seen this past summer with the urban heat islands and the heat waves across the globe that mountain tourism actually spiked because people were heading to the cooler temperatures of the mountains. Some of the challenges are going to be that, of course, we'll have altered environmental change. So flora and fauna is going to change. We have glacial retreat. There's concerns for visitor safety, but we don't really know how that altered accessibility or last chance tourism is going to play into this. So as you can see, the green are positive for green mountain tourism, red are concerns, and gray is we really don't have a clear understanding. Golf tourism is similar, a lot of strong headlines for telling that it's on borrowed time, but we're starting to see, again, there's a longer season to golf. We're starting to see increased acceptance of unmanaged turf. And we're even seeing pro golfers such as Tiger Woods advocate for more brown grass. And so really our consumers just going to shift their level of acceptance when we have extreme events such as at St. Andrews where it floods the greens. It just seems to, at this point, be a temporal shift in terms of the timing of when people golf, but people haven't stopped altogether. This was a really great article that was put out in 2021, looking at the tourist hotspots most at risk of drowning. But again, when we're looking at this, it looks very doom and gloom, but the yellow is at high risks of flooding versus disappearing. And how tourists are responding to flooding, again, as they're shifting the timing of their holiday. It's not that they're no longer going to these destinations. We have small islands at risk to sea level rise. Again, not to discount those islands that will diminish as a result of sea level rise. Certainly tourism is going to decline in those regions. But what's not talked about as much is erosion, which chances are that's actually going to be the larger deterrent. But what we don't know very much about is how tourists are going to respond to adaptation measures. So if you look on that right side, there was a study done in Mexico. It's the only one so far that's been done, but those are called geotextile bags. They're essentially fabric bags filled with sand. They were used to protect the coastline from erosion. And when the study surveyed tourists on the beach, what they found was surprising, that people were actually empathetic to the need for adapting to sea level rise and erosion. And they found these geotextile bags as an opportunity for recreation. So it wasn't considered a negative. And in fact, there are many tourists who said that even if the prices got cheaper, then they'd be willing to go to places perhaps that are considered less sort of idyllic because of these adaptation strategies. So overall, then, to conclude, I think it's important to recognize that when we're thinking about where tourists are going to travel and how we sort of interpret these media headlines, is we need to consider climate thresholds for society versus human thresholds to climate. So we don't have to look hard to see these mounting headlines for telling sort of doom and gloom of the tourism industry, but the reality is climate change is multifaceted, and tourist responses to such changes are inherently complex. There's no denying that climate change is going to transform the sector, but the snapshot headlines are highly deterministic. So there's this assumption that climate change will have a change in climate resources and tourists will automatically respond by no longer traveling to that destination. But as I hope I've demonstrated, the responses can vary and often with conflicting findings in both the research and what we observe. So what's a deterrent for one tourist may in fact be a motivation for another. And I think sort of the last piece to end on is that regrettably, the impacts of many early onset climate change events, such as how tourists are responding to heat waves or hurricanes or ecosystem changes, quite simply is not being studied. There's not a lot of scientific literature, and this is a missed opportunity and something we must begin to explore in earnest if we're really going to understand long-term shifts in travel patterns.
Great, brilliant. Thank you, Michelle. Very much appreciated. So we're going to move into the panel. If I can ask the other speakers to switch on their cameras. If you have any questions for Michelle directly, please put them in the Q&A, but we're going to move into questions generally for the panel now. I can see a couple of questions coming in, and I guess a question for all of you is around design. There were a couple of questions that came out after some of the talks about the design of the vehicles. So if we're talking about road, are we seeing road vehicles, the change in design to adapt to some of the things that we're seeing with climate change, whether that's flooding? Are we seeing changes to aircraft, I guess in reduction of weight, for example? Are we seeing change to rail freight, that, just seeing, because they can become more all weather dependent, I guess, rather than having the impacts. And I guess for Michelle, I guess we're not talking about vehicles, but are you actually seeing any change in tourist behaviour regarding them maybe thinking about their carbon footprints and actually looking for holidays that are a low emission kind of option. So I'm going to start actually with Erica. We'll start with rail, and then we'll go down through roads into sea, and then air, and then finish with tourism. So Erica, I don't know if you want to go first.
Yeah, thanks very much, Liz. So I'm not aware personally of changes to the design of trains in terms of the fleet that there is now. I guess there are lots of other drivers for changes in design, and maybe the changes that there have been are perhaps being driven by those. The one thing I will comment on is there is an infamous case of again, I seem like I'm obsessed with Dawlish, but it is a very interesting location railway-wise. There were trains that were deployed along that route a few years back, and they had some very important electrics on the top of the train. So, of course, as soon as you get seawater thrashing up over at Dawlish, then those trains would basically not function anymore. So those trains are no longer used along that route, and instead other trains are used on that route that will cope much better with that kind of weather. So that's one sort of immediate adaptation, I would say, rather than a longer term one.
Great. Tyler, what about roads? I mean, just thinking about the vehicles that are coming, autonomous vehicles, EV vehicles, what are we seeing changes, and how are they going to adapt to kind of the changing conditions that we see on the roads?
As you kind of allude to, Liz, I think that's kind of already started to happen, and we're going to kind of concede that those who are in the planning stages, those who think of how to build these vehicles more efficient, more carbon emission, net zero, or that's kind of the idea that climate change is part of that we need to think of things that with the heat, specifically heat with the pavement, that stuff doesn't start to break down with the vehicles. As I kind of allude to in the question and answer conversation, it's just not even that, but it's also that we're going to probably start having weather technology saying, as you're traveling through a route, whatever that route is, if there's adverse weather going on, it's probably going to be integrated that in 10 minutes, you're going to hit the downpour, you're going to hit gusty winds, or you're going to hit snow, whatever the adverse weather is, that's going to start to come in. And it comes down to integrating that into how the car operates, especially if it is autonomous. And we're going to probably start seeing that probably within the next couple of decades, if not sooner.
Right. Caroline, what about on the sea? Any changes in design because of changing weather conditions?
I mean, I think as a couple of the other panelists have already alluded to, there's always a progression. Like we've seen boats originally, with big sails and taking weeks to cross the Atlantic, and obviously the ship designers, they always have a movement towards making those vessels more sustainable, more economical, more efficient, and I think that's basically going to continue. The only thing that they might need to start taking into account more is that they might need to, if we are going to see more extreme weather, more extreme winds, more extreme seas, maybe rather than just making the vessels more efficient, they might need to start taking into account being able to withstand those greater impacts, on winds and waves. So I think, there's always a progression of, of improving things, but I think that might shift slightly to being able to withstand, like I say, greater conditions.
Great. And Paul, about aircraft, I guess when you go on some aircraft now, they've definitely stripped down the inside to bare minimum. The seats tend to be not quite as luxurious as they used to be. I guess that's a kind of weight issue as well. But are there design changes going on in aircraft?
I think so. I mean, one thing turbulence does is it generates a lot of wear and tear on the airframe. And so it's possible in the future we'll see there'll be more exacting design specifications just to make the airframe more robust. And something that's already happening is the airframe itself is getting lighter on an average plane. So the older planes used aluminium, which is very heavy, whereas modern planes like the 787 use carbon fiber material, which is much lighter, and that's very helpful for the takeoff weight problem in hot air. There are other solutions to that problem, apart from modifying the aircraft specifications. Longer runways would help. Of course, not always possible to extend a runway. There might be things in the way. But if we could extend a runway, that would help, because you can attain a faster takeoff speed, and that helps generate more lift as well. And the other solution that is already used in hot countries in the Middle East is to schedule the departures not in the middle of the day when it's really hot, but first thing in the morning, last thing at night when it's a bit cooler, and that denser air helps to generate more lift. So there's a mix of things we'll see, including changes to aircraft that are already happening. But if we could have longer runways as well, and a different distribution of departure times, I think we'll need all of these things in the mix.
Great, thank you. And Michelle, as I say, I guess, have we seen a change in tourist behaviour looking for kind of those low emission type holidays?
I would love to say yes, but the reality is no, we haven't seen that shift quite yet. In order to reduce carbon footprints, obviously traveling domestically would be ideal. Traveling by rail would be ideal. There's certainly the biggest CO2 emitter for the industry as a whole is not only transportation, but aviation specifically. So if tourism as an industry is going to decrease their emissions, then we have to fly less.
Okay, so Isabella asked a question. So this is about the models, I guess, that we're using for the various areas that you're focusing on. So I think, Paul, you did touch on how the kind of predictions that you're using, where they come from, but just thinking about the different sectors, are we using ocean atmospheric coupled models? Are we using regional models? Are we using soil data so we can work out kind of soil moisture? Are we looking at climate models? And I guess it's a combination of all of these things, but can each of you just say a little bit about the models that you're actually using to make your various predictions, whether that's short range forecasts or the kind of longer change climate? And again, I'll start with Erica. We'll start with rail.
Okay, yeah, thanks. Great question. So, I mean, most of the work that's done in the UK for the rail sector is now looking at the UK CP18 climate projections as the source of information. So, I mean, I could be here all day describing UK CP18. So if you want to look up UK CP18, then searching for that on the internet should hopefully do the trick. But let me just tell you very briefly about sort of the methodology that I tried to use in a piece of work that I did previously using the UK CP09 projections. And that was sort of looking at heat-related impacts on the railway from that generation of models. And that was using regional climate models, several different runs of the same model, so tweaked a little bit to give you slightly different outcomes depending on the input parameters. And what we did was we talked to the railway folks and said, look, what are the kind of thresholds that matter to you? And so, for example, they might have said to us, well, when the rail temperature reaches a certain temperature, we have to send watch person out to look at the site. We then use an empirical relationship to translate that rail threshold into an air threshold, so something we can model in the model and project forwards using models under different scenarios. So that's, if you like, a proxy for the actual impact that's projected to happen. So that's how we did it previously. I mean, there will be other ways, but that's one that I've tried.
Great, thank you. Tyler?
For us here, we not necessarily looking at the climate models, even though we use them especially for seasonal and looking for climate change, but in the day-to-day, we're using the deterministic, the ensembles of the global models, the GFS, the ECMWF, the Canadian, then as we get into specific parts of the world, we'll start using more of the regional. So here in the US, the HRRR, the NAM in Europe, the UK Met, the ICON, over in Asia, JMA, and things of that. So in each part of the world that we look at, we start on the global side of the models, and we start going smaller and smaller towards the more regional ones to help us fine tune the forecast.
Great, thank you. Caroline?
Yeah, I would say for us, it's very similar to what Tyler's just described, actually, because we obviously for shipping routes, then we're using very big global scale models. And then for like the smaller scale port forecasts, we're using, much more localized ones with very small, very short resolutions, so that we can really drill down into those local effects for the ports. So it's a combination of it. And again, we're looking most of our customers are looking at day, maybe 2 or 3 days ahead. So those regional models capture that very, very well. So that's basically kind of what we're focusing on. They're not so worried about kind of after day 3. They're focusing on what's really going to affect their services in the next few days. And then, so for us, we don't use the climate models quite so much. I mean, obviously we do keep an eye on what's happening and how it's changing and how the seasonal patterns are shifting. But really we're kind of focusing very much on those kind of daily small scale changes.
Great. And Paul, I know you covered some of this in your talk. I don't know if there's anything else you want to say about some of the numerical predictions that you're looking at.
Well, it's very similar to the previous speakers. I tend to use these things called GCMs, which used to stand for General Circulation Model, a model of the circulation of the atmosphere and ocean, although now I hear people calling it a global climate model, which happily has the same acronym, although so these are coupled models, an atmosphere model coupled to an ocean, coupled to sea ice, and increasingly we actually call them Earth system models. So it's the whole Earth system. And in fact, the really latest term I've heard is digital twin, which I'm not entirely sure what it means, but I think a model that's so good, it's kind of indistinguishable from satellite observations, really. It's so high quality, so good in resolution. So these kind of models that tell us about the temperatures, the winds, humidity, clouds, precipitation, etc. in the atmosphere and ocean.
Thanks. And Michelle, I guess a combination of models that you're using, whether it's climate models, but you're obviously collecting lots of data, people kind of data. It's very behavioural, and you showed a lot of that in your presentation, just asking questions about, whether it's temperature thresholds or whatever. What kind of things are you, using? I guess what models are you using?
I echo the previous speakers. It very much is in line with what Tyler is talking about. Obviously, every study will use a slightly different model. In the ski work that I do, we do a lot of climate change downscaling, but it's also important, obviously, to look at elevation data as well to see how the snow is different at various elevations. So depending on the study, any number of models could be used.
Great. So a question for anybody who's involved with this. If there's ever an accident or any sort of disaster or problem that's caused in any of the sectors that we've been covering, whether that could even be tourism as well, do any of you get called in to comment or provide information to kind of look at this, or even use it as a case study for future changes, whether that's in model data or communication or changes to the infrastructure? Do any of you get called and involved for that?
Yeah, so sometimes when at the end of a vessel voyage, we would do what's called a voyage analysis, and basically we give the vessels all the different data that they might require. And obviously if something has happened during that voyage, then that's one of the things that they'll come to us to discuss the weather and what happened, whether that was because the models went wrong or because something happened, something changed, and whether there was a breakdown in communications or all the sorts of things that can kind of affect that. So yeah, we definitely get called in for doing those kind of analysis of the routes as well. And then on the other side, even we haven't really touched on this sector, but like offshore oil and gas as well, if there is ever an issue, maybe a crane's broken down or has been swung around in high winds and they were not forecast particularly well or something like that, then that's obviously something that will come, they'll come back to us to do different studies on. So yeah, we do definitely do that.
And I guess Erica and Paul, you're probably looking at case studies, events that happened, and you'll look back at that and kind of why it happened, what might happen differently. I guess it's rather than maybe getting brought in if something happened, it's actually using it as a really good case study to help kind of make a difference in future.
So, my team that I currently work in at the moment, we do actually do, as well as my sort of experience, which is more on the climate change timescales, my current team does actually do low adhesion forecasting, so forecasting for the leaf fall season. Yeah. So you might remember last winter there was a low adhesion incident at Salisbury, and there was a derailment. We were asked to do some post-event analysis for that. So yes, we do get pulled in to do that sort of thing occasionally. I'm sure there are other teams in the Met Office that do that too.
Yeah. Paul?
Yes, similar picture here. I mean, we've all seen, you know, on the TV news, this footage shot by passengers inside a plane when it's in the middle of turbulence, and people being taken off the plane on stretchers. So I do get called up. In fact, I know as soon as it's happened, because my phone starts ringing, I know it's going to be someone asking for some comment. And of course, the question they always ask is, has climate change caused this turbulence encounter? Which, I mean, the answer is neither yes nor no. The answer is that's the wrong question to be asking. In the same way, we can never say climate change caused a heat wave, but we can say it's made it more likely. That's the slight subtle thing about causation in science. Cause A causes B is quite a subtle concept. So my response is that yes, this is the kind of turbulence encounter we expect to see more frequently because of climate change, but that's subtly different from saying what I think some journalists would like me to say, which is climate change caused this turbulence encounter. So we should be blaming it on climate change. It's a more subtle picture than that, of course, in reality.
And Tyler, I think you brought this up in your presentation. You know, we put severe weather warnings out, and you know they're there to, you know, help the public to make decisions to keep themselves safe. And sometimes people do not respond to these severe weather warnings, whether it's flooding or strong winds. You know, is there any work that you do at AccuWeather that tries to look at how we can kind of, you know, deal with behavioural change and, you know, ensure that when we get these messages out that are there to help save lives, that people do actually, it's a call to action, isn't it, really?
Yeah, we try to, in the forecasts, add what we call special statements, so enhancing the forecast to give them the idea that there's going to be adverse weather. Even on the converse side, tomorrow could be a great day to be outside, something that adds context to the forecast. It's interesting. It's a social problem, just not in the US, but globally. Last week, and I can't believe it's already last week that this happened, that the Europe Conference on Severe Storms had a online conference, and one of the guest speakers on the second day was a researcher out of University of Oklahoma, who dove down into survey results of weather warnings. And the interesting thing that I found out of that is if someone lives in an area that constantly get, let's say, a tornado warning or a severe thunderstorm warning or a flood warning, the likelihood of them actually taking action decreases because it happens at such a high frequency, versus if that same area was to get a winter storm warning or a warning for snow, they're more likely to be more alert, more active in taking precautions. And I think we kind of see that with how Hurricane Ian went into Florida. I had a classmate of mine from high school, primary school, who lived east of Naples, just east of the airport. And another friend of mine said that he didn't evacuate. And I'm like, what for? The surge water is going to be going miles inland. And the response was, I was comparing it to Irma that went through, I can't remember, a couple of years ago or something of that. And I'm like, that's the perception that we have to break down. We heard it after the super outbreak of 2011 with the tornadoes. I didn't think the tornadoes can come over the hills, the mountains, or they go through cities. Those are the perceptions that, even though it didn't occur, if it doesn't necessarily occur all the time, or it never has happened in someone's lifetime, or it happens all the time, those are the barriers that we have to break. And that's what the social science right now that is with meteorology has to be looking at, because if 50% of people aren't paying attention to flood warnings and going to drive into water all the time, that we have a problem then, because that means they're not trusting us, they're not trusting the warnings that are being sent out.
Yeah. Michelle, I think just leading on from that, I mean, you talked about, you know, the images that are used in the media when we talk about heat waves, and in the UK that's a major problem for us, you know, because in the UK the weather tends to be not, you know, particularly hot and sunny in the summer. So when we do get these heat wave events, people kind of celebrate them rather than seeing them as actually dangerous events. And the media can really, you know, put images, as you say, of people enjoying the hot weather on beaches. Have you thought about, when you engage with people and ask these questions about is it too hot, what temperature, what threshold becomes too hot, actually using images that actually portray, you know, the real dangers of the heat to kind of get that message into their head and then ask the question rather than, you know, because again, the images of enjoying hot sunny weather, and it's associated with kind of holiday weather, people are, you know, their answer to the questions will be a little bit different than if they actually see 39 degrees is, you know, very dangerous for us. You've got your microphone muted.
You'd think this long after the pandemic, we would get that straight. That's a really interesting point. I think with respect to my own research, I actually haven't done that on purpose because I don't want to bias the answers or lean people towards thinking that I'm talking about climate change. Admittedly, I've never really thought about the inherent dangers of doing beach tourism in a heat wave. There is very little research, though, that looks at how media headlines influence the decision on whether or not people go to particular destinations or don't. It's an area that we certainly need to look at, and what you mentioned could be added to that list too.
Great. Okay, so conscious of time, we're coming to the end. Just a really big thank you from me to our speakers this afternoon. It's been a fascinating kind of whirlwind tour around the different transport sectors and tourism itself. So I'm sure everybody on the call will join me in thanking you all. Big round of applause from me. Big thank you as well to the team behind the scenes for putting this together. That's the organisers and my colleagues at the RMETs who pulled this together. We'll be sending out a feedback form. We run this event annually each year and the topic changes each year, but we do welcome feedback on the kind of things you like, different topics you might want to see in future as well. So please do fill in the feedback form. But yes, I'm going to just close off there, just saying a big thank you to speakers and also thank you to everybody who attended as well. So bye from us all.